So I want to start the whole day with an overview of what DevOps is and our journey, what Microsoft's journey has been around that.
Can you hold a small second? We are not live on YouTube. Will you please
Oh, sure. I'm freezing. Thinking, connecting. Wi-Fi. No, we do. We are back on track. Good. So for those who were disconnected until now, what I was saying is that we will start with a quick overview of what DevOps stands for. I will explain what has been the DevOps journey at Microsoft, how we've been evolving our software development practices within the different teams at Microsoft. How we evolved from the traditional waterfall approach to something a bit more agile or DevOps-y, I would say. Then we'll talk a bit about planning, what planning work stands for, how you organize your work, how we can manage the work from different teams. After that, I will touch a bit around continuous integration and continuous deployment, which could also be said to automatically build, deploy, test your software. We will cover a bit telemetry. So roughly that should be end of the morning. We will talk about telemetry. Testing in production. I hope to reach that around the early afternoon, after lunch. We may have a bit of a delay, but we'll see. Then I will walk through what experimentation or A/B testing stands for. And we'll conclude the day with fault injection. So I have a bunch of hands-on labs, a bunch of demos that we have around that, and I will walk through with you around those things. Couple of housekeepings. We'll try to make a break around 10 to 10:15, so you can refresh, get coffee, snacks, restrooms, all of that. Cigarettes for those who smoke. At 11:30, we'll try to stop for lunch until 12:30. We have an hour break for lunch. And then we do another break around 2 to 2:15. End of the day will be around 4:30. I will not be super sharp on that. We may finish a bit earlier, we may finish a bit later, but expect end of the day around 4:30. There is no stupid questions. I want to ensure that we are clear on this. So if you have any question, if something seems not super clear for you, please raise your hands. Or for those who are online, ping the people monitoring, and we'll take the questions. Nothing is stupid. There are only bad answers, and that will be my fault. And the rest is just enjoy. Any questions so far? We're good? Perfect. So enabling DevOps practices. So why DevOps? And let's look at Microsoft, let's be honest. Microsoft was built in 1975. We had a certain methodology for building software, the very traditional way. Microsoft was building that software with a very waterfall approach. However, think about it, 5-6 years ago, we've seen big problem arriving. The process that we had to build software were not following the business changes that were happening in the world. The world was changing fast, dramatically fast. And at the same time, there were new companies arriving, which were capable of evolving faster than Microsoft was capable of evolving. That business change was actually jeopardizing the survival of the company. Our competitors were going to take market shares by being more agile, being able to evolve faster than what we were capable of doing. Just to give you an idea, back then our development process, we're thinking about roughly 2.5 years. That was about the time it was the time necessary to build solutions like Office or Windows. We were starting with planning phase, and I remember I was kind of connected with those teams at that time. people were thinking of, wow, what do we need to put into our new version? What will be the next version of Office? Let's put this and that. Then, in those buildings in Redmond, there were people going to their cubicle, writing code with their team. They were building stuff. They were super happy. Yeah, oh, we'll do that. Oh, yeah, let's code this and this and this. Let's move on, let's code. And then came the problem. They had to stabilize and integrate all of that. There were people calling it the war room. War like big fight, because each team was going to fight. I've done it the right way. No, you have done it the right way. No, you should fix it. That's your problem. No, it's your problem. That was going endless. That is when we started to have betas. For those who have been in this industry for some time, that's when Microsoft was shipping those betas that were not stabilized. Things were broken because the teams were not agreeing on what to be fixed, what had to be fixed. Then they had to code and fix it. So we had the beta 2. And then potentially we had the beta 3 until we had to code again and fix it again to go to a release candidate. Potentially RC1 and then RC2. And eventually, 2.5 years later, we got the RTM, which was a compromise between a certain number of bugs and a certain level of quality. Some features didn't make it because there was so much waste in the process that not all the features we had in mind could be implemented. It would have been too complex. It would have been taking too many resources to be able to achieve that. So that's when we started to have the approach of DevOps. And what is DevOps? I'm sure I survey everyone in the room and online. Everyone will have a different word or a different definition of DevOps. It's like what we use in the US as what they call in the US the elephant in the room. It's a big thing that everyone sees and everyone has a different opinion. But we talk about the same thing. So some people will say it's a job title. Some people will say it's automation. Some people will say, well, you know what? It's development and operations collaboration. It's all of that. It's a bit of each, actually. It's everything. And as Microsoft changed, we changed our life cycle. We converged the way we were looking at development cycle to a converged approach. That converged approach starts with planning and tracking. So when we plan things, we actually plan things in mind of we need to track what's going to happen. We need to track what's happening in our systems. And of course, it's easier if you do it with online services than if you do with software that is installed on your PC or your machines. But it actually works the same way. When we release Windows, we have telemetry into the operating system. The telemetry helps us to understand what's happening, what people are using. Are people having the right experience? Then we develop, after we've done that planning and tracking phase, thinking, then we start developing the solution and implementing tests. Then we will release in production to monitor and learn. We monitor how the thing is behaving, how what we've been developing is behaving in real life. Then we release that. That cycle is actually operating for each single feature, each single capability we implement in our solution. It's not something we do for the big purpose, but we also do it for each feature that is implemented. I'll tell you a bit more about that in a minute. But it requires a conversation that goes on 3 levels. It's a people, process, and tool combined together that enables this methodology. You can think of it, well, if I have the right tools, I will be able to implement how people work, and I will be able to implement my processes. Well, it does not really work like that. You can buy the greatest tool and still do a bad job at developing software. If you don't have the right mindset, if you don't have the right philosophy in your teams, the tool will not be used the way it should be. And DevOps will not be implemented. You will have a DevOps-like at best. People need to understand that collaboration is key. People need to understand that they have to share a common goal. And if the teams have different perspectives of what they need to achieve, DevOps will never work. So it's a really big change in people's mind. What is DevOps and how they should think about it? Now, on the processes, interestingly, processes is not changing how you do the handover or how often you do your meetings to see how process is going, how the progress is being made on a specific project. The process discussion is how you eliminate waste on how you build software. I'm going to look at everyone in the room. Do you know how much time is wasted in your processes? Each of you, think of that. Do you know how much time is wasted in each of your processes between the ideation to code in production? If you can say, yes, I know, it's that many days or that many weeks, then you've already made a step towards DevOps. If you don't have that answer right now in your head, I will teach you how to do it. But you need to think about it and potentially do that exercise with your team. I've been working with companies, and I'm not going to name any for confidentiality reasons, but I've been working with some companies. The time between ideation, so when they have an idea into the business area, and code implemented in production, the elapsed time could be something like a year. Waste time in that process was over 6 months. So basically, they were doing 6 months doing nothing, but waiting on other teams, waiting on things to be implemented, waiting on processes to be done, instead of actually working. The process is an important piece to identify and accelerate that methodology. How you streamline the process, or how you streamline the value from beginning to end. And at the end of the day, tool is important. It will facilitate the discussion. But I would say the tool is only 1/3 of the conversation. At Microsoft, we've identified what we call the DevOps habits. Oops, went too fast. The 7 DevOps habits. So that's how we defined what we are doing. We define the flow of customer value. We define what is the autonomy and alignment. How do we reduce our backlog based on our learning? How do we learn from our current mistakes? Not by blaming other teams, but how do we learn from a current mistake to not reproduce it? How do we ensure that we have a data-driven conversation by collecting data in production so we can actually get those evidence from real life? What is our technical debt? Do you know what is technical debt? Rough, yes? Okay, just wanted to confirm that. And how do we ensure that production is first in our mindset? What I mean production first is mindset is, and I'm going to potentially scare many of you, we don't do QA. We don't do staging. Code ships in production. Why would you do QA? If you're confident with what you wrote, ship it. If not, don't ship it. If you have the slightest doubt that your code is not stable, then don't ship it. And think of infrastructure as a flexible resource that will adjust to your needs. And that's when we rely on the cloud. The DevOps practices that align to those habits are the traditional practices that you may have heard of. Flow of customer value connects to automated testing, continuous integration, continuous deployment, and release management. Autonomy and alignment aligns to agility, self-managing team, and feature crew. Backlog connects to usage monitoring, telemetry, testing in production, shareholder feedback, which means customer feedback. We want to know what customers have or use. Evidence gathered in production, testing in production, usage telemetry, user telemetry, feature flag, interesting conversation too. Experiments, experimenting in production. Have any of you already experienced a different interface, let's say on Facebook, than your neighbors or your friends? I see a few hands. Facebook is actually doing that every day. They actually deploy and launch experiments on some of their capabilities and see how those users, their users, are using that in production, collect the feedback, collect the usage, and see how it has been received before they deploy it at a broader scale. My wife has a different Facebook, totally different Facebook than me. She has way much more users and much more followers and friends than I have. She has a whole different interface. I'm like, is that Facebook? She says, yeah, it's. So they're actually picking people based on certain criteria. Number of followers, or number of friends being one of them. Technical debt. Peer code reviews or peer coding, automated testing, continuous measurement, documentation. Production first, as I said, application performance management, infrastructure as code, continuous delivery, and infrastructure as code, dev test, automated scaling, containerization, microservices architecture, which is a whole different discussion, can fit into the infrastructure as a flexible resource. So, flow of customer value. How did we improve that? So we've implemented continuous integration and continuous deployment, release management, and automated testing. I want to pause here on the automated testing. And by automated testing, I want to say how key and important it is. In certain teams like Bing is a team we can nominate, they have a case study that you can read if you want to go deeper in that. They actually have their test written before they actually do the code. Every feature that is implemented in Bing needs to pass thousands of tests. And I mean, they're not going to say, oh yeah, we can pass that test that failed. No. All the tests have to be passed before that code is actually checked in production. Basically, they've switched the conversation from, oh, we're going to write the code and we're going to test if the code works, to let's write the test first, make sure that those tests are actually successful, so we know actually what we want. And when that has been done, then they write the code, and the whole thing has to pass before they release in production. That was an important shift, an important change in how Bing has been working and how Bing developed their solution, which allowed them to go from a release every 3 weeks to multiple releases per day. One important topic: team autonomy and alignment. That requires a lot of support from the management chain as well. How do you create responsiveness in your organization? Well, if you need to get the approval from a senior VP to implement a single color change to go from blue, dark blue to light blue in your environment, that's not going to work. You need to delegate. The teams need to get that autonomy back in order to be responsive. That's how they're going to react very fast to a fast-changing environment. They need to be flexible in their scheduling and have short iterations. If your teams are starting to code and they're almost like in a tunnel for the next 3 months, that's not agility. That's not what I call agility. They need to be able to change what they're working on almost on a weekly basis. Basically, on a Monday, they know what they're going to work on. They're going to implement it until the Friday, and then the next Monday, they're going to switch completely. Maybe the business has changed. Maybe a competitor has shifted something in the meantime. And you want to switch immediately. Each team must have their priority, but their autonomy as well. And that is important to gain that customer responsiveness. So at Microsoft, there is the Visual Studio team. They actually run sprints of 3 weeks. So the VSTS team is running sprints of 3 weeks. That's how it works. They plan their sprint at the beginning of the first series of 3 weeks. They get the work done in that at the end of the 3 weeks, and then they deploy. At the beginning of the team, at the beginning of the sprint, they send the plan. At the end of the sprint, they share what they have accomplished with code stories, results. This is a couple of examples that we have. Here's the thing we're going to work on. This is what we've done. And sometimes they have done only 10% of it. Sometimes they've done all of it. It's part of the planning. That is connected to the idea of the increased autonomy, increased alignment, and autonomy. But it has a consequence. You cannot keep your team organized with the same role. You need to change how the teams will work. People will have changed a bit their role and disciplines. And at Microsoft, we had 3 different roles, very clearly defined, with different perspective. The program manager, he was the guy connected to the business. He was the person thinking of, are we doing the right thing? Are we doing the right features? Are we implementing the right thing in Microsoft for our business purposes? Then we had a developer, the coder, the person that was actually writing code, good quality code, making sure that the code was good with the right test being done, very well polished code. And then you had the QA person that was ensuring that the quality was here, ensuring that what was done by the developer was actually correctly done. Now we have a PM still ensuring that we're doing the right thing. We need that business acumen at one point. We need to understand what the business needs to make the product successful. But we have only engineering. Dev and QA is the same thing, technically. They write code that is fast, reliable, well-engineered with quality that meets our customer needs. So what does that mean? That means that writing tests and code is the same thing. And everyone is responsible for its part of the code from beginning to end. The other thing is how teams were aligned, or how teams are organized. A while back, we had a set of teams from PM, a set of team of engineers, and a set of team of testers. So of course, they work together, but they don't necessarily have exactly the same priorities in terms of the PM wanted to get the features out very fast. However, the QA wanted to ensure extremely high quality. That wasn't necessarily aligned. They were potentially having tensions here. Now, we actually have the reorganization. The PMs are together, and engineering works in teams. The teams, they're about 10, 12 people. They're very self-managing. They have their own autonomous backlog. They do not depend on someone else to do the backlog. And we keep them intact for 12 to 18 months. That's pretty much how we keep things going together in a smoothless environment. They go across the disciplines of engineering, software development and program management. But that doesn't work like that. It doesn't happen magically. It happens through also physical changes. I don't know if you've read a lot of articles around Microsoft that had the office, like people had their own office, and you could go in your office, close the door. My office is like that. I still have one of those. But most of the teams in engineering have evolved to small team open space. 10, 12 people in those open space, which facilitate the collaboration, which facilitates the reorganization as well, which facilitates the cross-team collaboration or cross-people collaboration. So you can go and do peer coding with your neighbor. One of the things you don't see here, but the desks have wheels, and you can actually change the desk very easily around the open space. So you want to do peer coding with someone that is across, and you want your machine to come with you? Take it and move it. It's that easy. There is no fixed organization, and each team has the flexibility of being organized the way they want. That's from the Visual Studio team, by the way. But that organization happens also in Office, and it gets into all the other teams as well. Question, yeah.
How did you go from before to now? Like, the transition was from top-down management decided, or was it people telling you how to work,
So I'm going to repeat the question for our friends online. So the question was, how did the transformation happen? Did it go from top to down, or did it go from bottom to up, pretty much? So it was, the initiative was given from the management, like this is how we should be, we should go. But it doesn't happen overnight. I will be very honest. It requires effort from the teams. It requires the people to be convinced that it's the right thing to do. And by that I mean, if you are a developer that has been writing quality software for many years, you do not change to a new approach overnight. You want to ensure that the code you're writing keeps the same quality. You want to ensure that you're not going to introduce bugs into the software you're shipping. So there are a few stories around available that explains how we've done that transformation. But what we've done, all up, is to ensure we had a data-driven approach. And by that I mean, when we started the transformation, we said, okay, now we're going to ship this feature in this approach. And we're going to measure how many bugs are going to be introduced by this. We're going to measure how fast it went out. So you give few indicators to your teams, and you see that those indicators go from high to low, or from low to high, depending on its quality or bugs. And that helps convincing people to go further into the process. But if you do it in one way, if you do like a big bang thing, you create chaos and it doesn't work. So you have to do it slowly, and you have to do it by teams, and you usually start with people who are convinced that it's the right thing to do. What I've seen in many companies, they kind of do a small group of people that are aside from the big development team, and they start operating in this DevOps mechanism. And then when they show results, and those will create a center of gravity so that you can actually shift gradually to this environment. But we had to go through a lot of training, a lot of convincing also from the management. The management had to be involved a lot into this transformation so that it went successful. But it was not like, hey, tomorrow we are going to be organized like that, and here you go. That was a bit more longer than that. Yes?
There is a question online.
Oh, okay, and I have 2 questions here.
Okay, so the question is from Thomas, and he is asking, why is PM in a separate team from development?
Why the PM are in a separate team from development? They are technically reporting to a different organization, but they are in the same V team. So it's more like the hierarchical approach, so that the PMs are evaluated against other PMs for the end of the year evaluation, rather than their work. On their daily work, they're mostly connected to their V team, which is within the developers. So that's more the evaluation, for the evaluation purpose than anything else. So first question is, what did we do with QA? Well, QA became developers, for those who wanted to become developers. For those who didn't want to become developers, well, they had to find other opportunities in Microsoft, potentially becoming PMs or other roles in the company.
So the main question is, how do you ensure that software engineers who put tens of years into mastering the craft of software engineering, even over time, but most likely quite suddenly become also experts in the domain, so they are able to write meaningful tests, for example. So now they should be both software engineers, masters of their craft, plus domain specialists. Search, maps, words, processing, and so on.
So the question is, I'm repeating for our friends online as well. So the question is, how do you transform people who have been doing software development, being master in their domain for many years, to being able to write the code as well as the test, which is not necessarily in the same language? And how do you do that evolution, that transformation? So I would say on that aspect, it's about learning a new language. Writing tests is, quote, just another language you need to learn. And of course, you cannot ask the same amount of development per se from those people than they used to do before, because they were focusing on writing code or implementing new features. Now they have to implement new features and write the test at the same time. So they're, and I'll be very clear, their individual productivity may be a bit less. But overall, the team productivity will be bigger. Oh, sorry. Okay.
Because I meant that, for example, I work in a company who works with financial stuff. So I have my expertise in software development, but I know almost nothing about financial stuff. So I have people who know all this stuff quite deeply, and we have several domain experts in different financial districts, and they know their
Okay, so let me repeat again, and it will ensure that I understood correctly. So you're in the financial sector, and you have to assess that the code you're writing crunches the data that are provided in the right way. So you have to assess that the data set that is provided to you, crunched by your code, returns the right info. And you have experts in each domain that does that assessment for you or with you. So I would say in your case, you would still need to get those experts in those domains. What your expertise is going to be is how you write automated tests that will actually do that job. Instead of doing it manually on, I don't know, 5 data sets, and I'm totally wrong maybe on the numbers, with automated testing, maybe you could provide 500 data sets, and your code could be assessed against all those things. What I'm saying is your job is not going to go and become an expert in this financial domain, but your expertise is more on writing the automated tests that will verify that your code doesn't have any bugs. So it's not verifying the result of the code, but more the assessment that your code is correctly implemented. Of course, in the case of the financial environment, you would still need to compare the expected result to the result you're producing. But that's kind of automated testing that you will implement.
Does it mean that those people fall in the group of product managers or expertly?
So those people who are in the writing of the test are software engineers. The data you put in the test is something that will be provided by the business. So in your case, the data set and the result of the data set is something that is provided by the experts in their domain. That's granted and doesn't change. However, what you're going to do is, in your specific case, you would take those data, you would write the test framework, implement a framework that will verify that what your code is doing crunched the number correctly. So they will not have to do the manual verification. They would do just an automated verification. That's what we're talking about in your case, for example. In other type of software, that would be a similar methodology. You write assessment, and those assessments will be implemented in an automated manner. Just to give you an idea, we are working with other cloud providers to do a tool that manages the different cloud solutions. We want to ensure that the tool does what it's supposed to be doing. So we write a set of tests that actually verify that what we order to the tool to do is actually what has been done on the cloud provider. Those tests are something we write. But what is in the content of the test is something that is done by people that will be knowledgeable on what we want to implement. However, I would say those people would have to learn a bit how to implement the solution, so they would have to learn code so they can talk to our test framework. In your case, making the analogy with your case, I would say your domain expert would have to learn how to write the test assessments. It could be a JSON file, I don't know what would be the right format, but that could be something like that. So they actually submit those files to you, and then they will not have to do those manual tests. So you can automate the process and redo it as many times as you want, if that makes sense. Another question here.
Okay, so what you've showed us up until now is that you've got program management and you've got engineering.
Correct.
Now, for very many of us, engineering is only part of it. We've got another group of people that we come to appreciate called designers. Mm-hmm. How do you bring that into the group? Because you said it was cross-functional, but you failed to, in my, I couldn't see that you were mentioning anyone else than engineers and program managers. So this is very software development oriented.
It is very software development oriented, and designing is part of that. It's part of engineering in a certain way. The design is part of software development.
Okay, but the way you're setting it up now is more towards engineering, and your example as well is Bing. which I understand has a very, very small touch point actually with the end user when it comes to the design and the user experience. And I'm failing to see how the user experience is properly taken into account in this setup.
So that methodology that I explained, this team actually is Visual Studio. VSTS. Also has many connection points with the user experience. Bing has many touch points with the user experience. The user actually changes almost every day. The user experience changes almost every day on Bing. This is also how Office works.
Okay, I'm not sure we're thinking in the same way.
Okay, so please.
A lot of what we're doing is not actually that engineering heavy. It's more of a user experience heavy.
Mm-hmm.
And so you're creating brands, you're creating things that has to do with how people experience whatever you are, for whatever your business you are.
Okay.
I think what you're doing here is solving more engineering heavy tasks than actually user experience tasks, but that's my opinion.
So what I can say is on the user experience, the teams that work in the different engineering groups that I'm talking about, the designers are also part of engineering. They are considered as engineers that work like coders.
Okay, if you say so, that's fine. But that's one way of solving it.
And that's why they are considered in the same group of engineers. The user experience is as much part of the software development than the code or the thing you don't really see or features that you don't really see interacting with the user. Both of them are as important.
Okay.
And the telemetry, I'm talking about telemetry, or I will talk with telemetry. The telemetry is as important on the back-end software than it is on the front end. We actually measure, for example, on VSTS, we measure where people click. We follow their path through the user experience from beginning to end to know what features are well implemented and what features on the UI, again, are appealing to users. And that's how the VSTS experience, the user experience on VSTS, has changed almost from night to day in the last 18 months. I don't know if any of you have seen VSTS recently, but if you remember how VSTS looked 18 months ago and how it is now, it's a whole different experience. And that didn't come by chance. It came because we've measured that when people had a build that failed, they were like, click, oh no, and they were coming back, and click here, no, and then click somewhere else. And now, when you have a build that failed, you have a new button that says, queue new build. That's based on the telemetry we implemented on the UI that made us learn that people were lost when they were monitoring a build that failed, and they were looking for that button. I'm not talking necessarily about the color and the design, but it works in the same way because you need to connect the UI experience with the rest of the coding. It's not disconnected.
Can I offer a comment?
Sure.
So I just wanted to offer a comment on that. So I've been working with a lot of companies that do DevOps or try to do DevOps. And they actually have their own design stages of a process because design isn't only the visual appearance, it's also the interaction design. And it's also about defining the approval criteria for any given feature that you have, so that there is more involved than just the visual presentation. The design process is actually very important. So, but having that separation between what is interaction design, so how does the user actually interact with your software, and how it's supposed to look in terms of graphics, is something that you plan for and you execute, you program, and you can test it as well. I just wanted to offer that. And yeah, just ask me for details later.
So the next topic, which is not disconnected, is around backlog, continuous improvement, and learning. It's very connected to what we just measured or what we just discussed. On our backlog, in most of the teams, we have a set of hypotheses. What we do, we take those hypotheses and we transform them into experiments. And those experiments, we measure the result, we measure the usage, and then we implement those capabilities into the software. Those experiments will not happen overnight. They do not happen when we started to implement DevOps. They're actually something that happened to be implemented a long time after we started to implement DevOps practices. One of the examples here, I'm going to pick the Bing example. I can show you later, but if you look for Bing on some of the things like doing math, you do calculation, you do 2 plus 2, Bing will also improve the UI and show a little calculator. I don't know if it happens here in the Norwegian market, but in the US, in some areas, in some case, it happens. That's an experiment. So we've implemented that experimentation, and it's the result of a hackathon that was done inside the Bing team. They did a hackathon for a week. They took everyone away from coding, their regular code, and they have been experimenting new features. Like, hey, what do we do if blah, or let's try to do this. And some of those ideas became experiments in real environment, in Bing. And then they figured it was working, and they are going to productize it and make it a bit more efficient. Some of the features were implemented and faded away because no one was using them, or it was irrelevant. That comes with user telemetry and usage monitoring. We also do A/B testing in production. Some users, for example, in Azure, you may have some experiments that are different. You will have the A/B testing, so some people will have a certain configuration and some other people will get a different configuration. And you measure the result of those two experimentations. So, evidence gathered in production. Testing in production, that's an important topic. I guess everyone has heard of Chaos Monkey. Chaos Monkey sounds familiar for everyone, almost. Okay. So, Chaos Monkey is a tool that was developed by Netflix, which is now open sourced. They're releasing their version 2 right now, almost. They're in their version 2 soon. Chaos Monkey does something very simple. Chaos Monkey goes and kills services that are run by Netflix in production, randomly. So, any of you think of your production environment, would you have the guts to go and kill one of your machines right now? One person, 2, 3, okay. That's what Chaos Monkey does. They go and randomly kill constantly in production some services. We are doing the same thing in some of our areas. And that's what testing in production means, to the extreme, I would say. But it's also about making some things more difficult, having fault injection, seeing how the system reacts to networking issues, so how the system reacts to some all kind of issues. That testing in production ensures not only the resiliency of the environment to all kind of problems, but it also ensures that in case of real outage, you have a system that is going to be performing 24/7. You remember the outage we had on Amazon, or that Amazon had about a month ago now, 2 months ago, a month and a half? It was early March, late February, I think. We had a big S3 outage, and you had a bunch of websites that were down. Well, you can say that those ones were not ready. They were not doing tests in production. They were not doing fault injection, or not at the right level. The thing is, when you go today in the modern applications that are relying on the cloud, yes, it's flexible. Yes, you have unlimited resources, unlimited capacity, quote, but pretty much technically a huge capacity, a huge set of resources available. But there is one thing I can say that's going to happen. It will break. I don't know when, but I can tell you, there will be an outage in the cloud. It will be tomorrow. It may be in a month from now. It may be in a year. Any cloud provider will have outages. Azure being one of them. We will have outages. I don't know which one. I don't know when. I don't know what is the importance of it. But there will be outages. What your application needs to be ready for is that moment. So you need to ensure that you have that completely done. The last practice that we also use a lot is feature flags. When you deploy new features, you don't deploy the new features and having that big moment where you're going to deploy the new version and everyone is paying attention to it. No. What now happens is you deploy the version n+1 with the feature implemented and the previous version of the feature or the non-feature implemented. And the feature flag is a practice that says, my feature is implemented in the code, but is not active. It is there, it is latent, and I'm going to wait a moment when I can turn on the feature so that when I'm ready, when my whole system is ready, I will activate that new feature and get it deployed or activated in the system. That's an interesting DevOps practice because you actually don't have that stress of deploying and activating at the same time. Technical debt. Technical debt is going against the quick and dirty fixes, basically. A quick and dirty implementation of code is never good. It's never good for today, and it's extremely bad for the long term. So think of it. You have a quick fix that you can do today in 5 minutes. But basically, it's if variable not null, then blah. Well, maybe you want to understand why the variable is not null. Maybe you want to go a bit further in the understanding of what the code is or what the problem is in your code. So it will take more time to fix it today, but think of it as an investment. It's like a longer-term investment. Or if you have badly written code, you deploy that badly written code in production and you have to fix it. Well, if you have to fix it in a year from now, no one will remember what the code is doing. And then no one will touch it. I can tell you in Office, we have pieces of code that are not touched because no one really knows what they're doing. That's the technical debt. And you're going to carry that debt for as long as your product will live. So before, that's how code was looking like. We were doing the code complete, we were doing test and stabilize, then we were fixing problems, the quality was getting better, and then we were increasing the number of bugs again when we were we were reducing the number of bugs when we were testing and stabilizing. So quality was improving over the test and stabilize period. Basically, when we had the software that was running for many years, those are number of bugs open on a real product of Microsoft over a number of years. So you could see that the number of bugs was actually really decreasing after many, many years. By reducing our technical debt and having shorter sprints, that's how our technical capabilities look like. So yes, because we improve and write smaller pieces of code, the quality, though the quality improves a bit less every single iteration, but every time we write code, we introduce less bugs. And with a lower technical depth, then we have less bugs being introduced at each iteration, so they're easier to fix, which means that we have shorter waves of fixing and bugs in case we have bugs. The last point I wanted to talk about is the infrastructure being a flexible resource. We use the public cloud as you can think of. I mean, in our case, it's Azure. We deploy those resources to the cloud. We use infrastructure as code. That's one of the main practices that we're using. We have solutions for developers. So developers have their sandboxing environment. So yes, they still test their environment. They do small development and testing in their systems. It's called sandboxing. And we are relying more and more on containerization and microservices. Containerization and microservices is a big topic right now. I guess everyone has heard about it. Basically, we rely on the different containerized orchestrators that exist today to deploy our services. It's still the early stages, but it's something we're using a lot. We also have auto-scaling in place and failover, meaning that we ensure that all the services that we deploy, based on the infrastructure as code, we introduce the same capabilities across different data centers, across different regions. So in case something happens super bad in, I don't know, West US, then we have a failover in East US. That's the kind of philosophy that we have for all our services. So in a summary, previously we were very focused on the planning. We were really focusing on making sure we were on-time delivery for our TM. We were basically having teams competing to make their feature go through. We had a very hierarchical approach with managers making the decisions for their teams and the manager of the managers making decisions for their bigger team. And we were focusing on individual productivity. The main focus was the individual during the previous organization, with the process being focusing on the efficiency of the process itself. And most of the discussion we had were around assumption, people thinking what would be the features that customer would use. In the current implementation that we have with DevOps practices, we're thinking on the delivery. Basically, a feature can be deployed in a week from now or more than that, but what we are focusing is the delivery of that feature. We collaborate to make sure that we get the agility with teams that are focused more on the collaboration piece than actually their individual result. So what matters is the result of the team, not the result on the individual. What matters is the output, the outcome, and how efficient that outcome was. And then the other big change that we have in the company is to be data-driven. There are very, very few assumptions being made. Most of the discussions we have now in the product team are based on data. We rely on those data to make our decisions for future implementations. That's how we do DevOps at Microsoft in most of our teams. and it's time for a break. We have 15 minutes break, and we will do a plan. We will see planning in action, and then we'll do CI and CD. Okay. Just good in time, just 2 minutes late to start. So just a quick update from the organizers. We will have lunch at 12 instead of 11:30. I've been said that the restaurant is more like 12 o'clock. So just expect to wait until 12 to get lunch. That being said, we're going to talk about the first phase of DevOps now. Let's dig into the first element, which is planning, the planning phase. So the planning phase is about starting from an idea and getting that idea in code and having that code go to production. So that approach in a DevOps philosophy or in a different DevOps organization goes from the philosophy of Kanban. I guess everyone has heard of Kanban. Yeah, I don't see any hands rising. Yeah, I guess everyone has been there. Just as a short history around Kanban, that's a Japanese term that has been invented by Toyota. That means the visual card or board. It was actually physically made as cards that were moved from a board in the factory, in the factories of Toyota, that actually, well, they were actually physical cards that were attached to the parts of the car as the car was moving along the chain. That's where it was used. And that was doing the work in progress. The philosophy around that is to eliminate the waste. That's always this philosophy of how do you go from a process that is oriented towards the efficiency of the process towards, hey, how do we eliminate the waste of time, of resources into that specific process? The Kanban relies on 3 simple rules. The first one is everything has to be visual. You want to have the workload on the cards, on the board, so that they're easy to see. At Microsoft, we actually have moved to a fully digital version, but there are still teams that would like to have the board and the post-it moving around, and that's fine. The second rule is the work in progress. The work in progress is limited by the capacity of each column. Each column has a maximum number of items that should be being worked on, which is ensuring that the team is being used at their efficient level. The thing is, if in a column you start having too many items, either the team is going to be totally dispersed into thousands of work being done, and nothing is going to be really worked on. And you remember one of the principles of DevOps is the efficiency. People actually getting things out of the door. If you start having people dispersed into thousands of things worked on, nothing is going to move. You're going to switch context all the time, and by switching context all the time, there is nothing being done. Try to do 1,000 things. I'm incapable of doing 2 at a time, so go figure if I have 3 of them. And you want to ensure that what is being worked on is limited by the capacity of your team, so you're not taking more stuff than what you can actually work on. And the flow of the card on the board is measured with the objective of minimizing the cycle time. The team will be more efficient if they actually get things done and start taking something new, rather than accepting thousands of items and trying to get all of them done. How does that work? That's how we use it. Well, that's one of the PMs at Microsoft who shared me those slides because it it was kind of fun for him to make it real and show how it was being used. So we start with a fresh idea, fresh project. We have 7 items on the backlog. Everyone is a clean board, nothing is being worked on. In red, you have the product owner. In blue, you have the engineers, the people writing code. And in green, you have the ops, which kind of now becomes engineers as well. We are moving those as well into engineers. First day, we take 2 items. So A and B are the most important things to work on. So we take those 2 items and we move them to the column being those are selected. So we start working on those A and B objects. The developers will start working on A, some developers will start working on B. All good, everyone happy. The PM starts to say, okay, now you can work on C and D. Those are selected. Note that C and D will remain into the selected column. They're not into the develop ongoing, because developed and ongoing has a limit of 2, and that capacity has already been reached. Number 2 is defined by the size of the team, obviously. So we're going to be in a stage where A and B are being worked on, and C and D will remain into the selected until something will move from A and B. I'm going to look back at VSTS itself. But the principle of VSTS is to create those backlog entries from the sprint, user stories, bug, and tasks. We assign the priorities of those objects or those work items and estimate the work effort. From the product owner or program manager, it helps manage the team capacity on what needs to be or what can be taken. And that has to be differentiated by specialty. So we were talking earlier this morning on the designers. Well, the designers, it's a specialty. And you cannot overload the designers by more than what they can do. Or you have a specialty on statistics, and you cannot overload the statisticians by what they can do. So you can actually filter and drill down on the capacities on those things. Interestingly, you can connect the work item with the code, and that's how it should be. You want to have those work items to connected with real code or real life code. And we can create branches for each of those work items. So you have a work item, you take the work item, you create a branch in your code, and you get that code being worked on. When the code is done, you do the pull request, and you merge the pull request into the master branch. So that's where we switch. I guess it's a bit too small. I hope you can see in the back, in the master left. Okay. So I have a project. It's called Deep Space. It's a simple project. It's a Java-based app. Just wanted to go a bit away from .NET to share different ideas around this. So I have my code. But what I wanted to show you here is the dashboard. So on that project, I have my dashboard that is connected to my environment. And let's say I have a team of people that are working on this project. And what I have here, I have a bunch of, I have a couple of user stories. I've created two. One is I want to add a new feature. I want to add a number of stars on the project, and you'll see how the app looks like if we can build it and deploy. And the other one is miss requirements, what is missing. That's the, I would say, my backlog in terms of features. I can go to my stories. I can add a task or a bug. I've already added two tasks. One of them is to add a counter slider. So for each of the tasks, when you create one, you define the state. It can be active, closed, or all of that. You can specify the area on which you're working. In my case, it's very simple. I only have one in this simple project, but you could have multiple areas of work. And you can connect to different iterations. So you have iteration 1, 2, 3, 4, etc. Each iteration is defined at the level of the project. And each iteration can be defined, you can define the name. And you can define different start date and different end date. So you can start today, and let's say we want to finish in 2 weeks from now. Yep. Did I say 2 weeks from now? There we go. So that's how you can adjust your iterations based on your organization. And you remember, I said that DevOps doesn't define how long should be your iterations. It can be a week sprint, can be a 3 week, can be a 2 week. It depends on your business. It depends on how you want to be organized. So going back to my task, I want to add a star count slider. I have a bunch of description. You can add elements around the discussion that's happening here. What is interesting and important is the effort. So we're considering that for that work, for that effort, we think it's a 1 hour of work. Your unit here can be minutes, could be days. It depends on how you're organized as a team as well. Here it's hours. We say 1 hour, and we haven't started it. So the remaining work needs 1 hour. The number of hours is going to go against the capacity of each column when you have your board. Then on the development side, you remember what I said? You can create a branch. So that's one of the cool features here. When I take that part, I can link this task to either different bugs that already exist in the system. So if I had different bugs being reported by users, I could record them here. But I can also say, well, I'm going to work on that task, and I'm going to create my feature branch, and I'm going to write code on that feature branch. So I'm not going to be distracted by what happens in the master branch. And then when I'm ready, I'm going to create my pull request. So it's based on deep space master. And you see I have one work item. I could add multiple work items based on the bugs. So you can relate a branch to multiple of those items, bugs or features or tasks. here we go. Going back to my board. So this is my backlog in terms of listing. Here's my board per se. So I have, for each of the iterations, each of the user stories, I have a line, and each of the user stories will show the different bugs, tasks that needs to be done, and then it's super easy to just move them back and forth. So you can create as many columns as you want. I usually have the new, active, resolved, and closed. That's kind of the basic stuff. You can create a new bug. And then you can assign it to someone. Let's assign it to Erica. And you've seen that the amount of work here is 21 hours, because the first task is 20 hours. The one that has 1 hour is here, the one active, based on the numbers. So it does the math automatically and allows you to identify where you're overloading your teams or when you're in good shape. That's in the capacity. So you can get into more details on the capacity of your team based on number of days off, based on amount of work that is done on this per week, per day. So you can say, well, per day, let me add someone in my team. So Julien, for example, only works 4 hours per day. I'm working, let's say 8, and my other avatar works 0. And on the right-hand side of the screen, you can see how much work has been assigned by activity and how much work has been assigned per person. So right now you see that Julien has nothing to do, he has 0 hours assigned, and Damien has 21 hours of 128 hours assigned. That's for the whole sprint. We're not talking about per day, we're really assigning by sprint. That work can go for 5 days or 1 day. It really depends, and we do the assignment on those. So you can do the assignment based on the capacity of each person. And you can say, well, on the activity that is, again, taking statistics, for example, on the statistics activity, I don't have enough resources today, so the work item that will come on this will be pending, and then it's a people's management discussion of whether we need more resources in the team on that specific capacity, or we can hold it and just delay the work that needs to be done. So you end up having a better management. The idea is to having a better management of the work of the teams. So you remember I've created a new branch in my code based on the work item. So now let's go to the work itself. So I wanted to add a new feature in my web app. I just don't remember. Where was it? I've lost. I've lost the code I wanted to change. Here it is. So I'm going to add the number of stars. I'm very easy, I've already commented the code. But what I wanted to show you is that I've changed my code, let's say like that. And I'm happy with it. That's my history. So now that I'm happy with it, I can create a new pull request. So I said I've updated flying star.js. I can add a description. In case you want to actually notify someone around the change you've made and the pull request you're doing, you can add someone here in the list with the little arrowbars. And you can define reviewers. So you can say, when I submit a pull request, I want that specific person to review it, or my team is going to review it. And in the system, you can also have a policy that defines that any pull request needs to be reviewed by at least 2 people before being approved and merged. It's connected to my, you remember my work item? My add count star slider, which is active. So that pull request is going to be totally connected with the work item, and we'll keep track of the history of that work item with my pull request. Pull request has been done. Now we can add some comment. I could do good to me, but I want Julien to review it. So basically right now Julien is actually going to get notified about it, and we'll need to go, well, can go and comment this. In my case, I'm like, I'm not very happy, I can redirect the pull request, or this look good, and I can just approve it. And when it's done, you can say complete. And it will actually do 2 things. When you complete that work, it will merge the pull request and delete the branch. So it deletes the branch, complete the merge. You can also have the option to squash and merge in case that's your policy in your environment. I like the, I don't know if you've played a bit with Git, but I like the ability to revert the change you've made. That's kind of easier than if you use it with Git. And the cherry pick, this is something new. You can cherry pick that so you can port those changes to another branch. So let's say you have multiple branches working on, you can cherry pick that one and port these changes into a new branch that is being worked on. So you can actually do an integration. Any questions? I have one here.
Yes, I noticed that the estimations.
And maybe a microphone. Oh, or I can repeat the question.
Okay, I have 2 questions actually. One is regards to the estimation.
Estimation?
You have real-time units in the estimations and not agile time units. Is there a reason for that?
Sorry, where was it? You mean in the task? Okay. The effort, yes.
My question is there a reason why you're using real-time units instead of agile estimation?
It's because I used a different template. It depends on the template you're using.
Can use agile estimations
Yes.
as well? Okay. And also, when you do this, the estimation, me at least as a developer, is horribly bad at estimating. I will, such as this simple thing, you think this is a simple thing, it will take me 2 hours. So I will estimate 2 hours, start working on it. And when I'm done, I realize that 2 days have gone by. So do you constantly update the tasks in the VSS to let everyone know? So you have to context switch between actually doing the work and doing the updates? Do you complete it and just say, okay, it took me 8 hours? Or is there some magic in the background that when you link to all the commits, it will actually say that you used 16 hours?
So I would love to have a magic that automatically update the amount of work I've done on a piece of code and make it to the work item. No, that doesn't happen, unfortunately. So you would have to fill in afterwards. And I'm saying it's a good practice to fill it afterwards, not every day. Although, and I will come to the everyday thing in a minute, hold it for me. Although, if you bring it afterwards, you will allow people or managers to do statistics on the work you've done. So if you go to the board, where is it? I don't have it here. Yeah, no. But on the board, you can have actually statistics based on how much effort is done on team and things like that. So you want to update those things, and that's my point, on a regular basis. And that's a team agreement. Like, do you do it every day? Do you do it every week? I would say the right rhythm depends on how often your PMs would connect and look at those data. If they do it every day, which I doubt, I hope they don't do it every day. But if they do it every day, then you potentially want to make sure that you update the estimated effort at the end of the day. The other thumb of rule that I hear very often is, yeah, everyone is bad at estimating how much work is done. So whatever you put, you multiply by 2.
Yeah, I usually do 2 times pi, and I'm still wrong.
Yeah.
So how do the VSS guys do it, of this team do it?
So the VSCS guys do like that. They do it, I think it's every day. At the end of the day, I've been working on this one for 8 hours. Bang, that's it.
Cool.
And they don't do very advanced calculation. They just, make like, I worked 8 hours on this. Bang, that's it.
And they estimate it at the start and just put a number and they just update it?
Yes.
Okay. Thank you.
Any questions online? Okay. So before I go away from here, before I go away from the code, I wanted to walk a bit around the dashboard. So the dashboard is, the way you can expose the work that has been done, statistics being done from a team point of view, from a project point of view, and all those data are available either through standard elements that are provided on VSTS, but they're also available so you can actually pull those data into your reporting system. So if you have any reporting system that exists, you can pull the data from VSTS and import them to you. So you can see what is assigned to you, the chart history, the work item, the deployment status. You also have the number of new work items, the pull request status, and we'll come into release definition and those things. You can also show the sprint burn down. That's an interesting one. The sprint capacity, it's more like your team. Team members, team room, the test chart, You have a bunch of those extensions that already exist. There's a gallery that allows you to extend those. So if you feel like you want to create something that fits your organization and you want to share it with the team, you can go and add an extension on the gallery and everyone can consume it. Cool. Once we've been working on the code, and you've seen some pieces already in what I was showing you, you potentially have seen at one point, it was showing build in progress. I don't know if you've paid attention on my screen, but I will come back to that in a minute. The discussion is now, how do you release, publish, deploy the code that you have built? The idea is you write your code, or you have your code repository, you write a code, and you want to automatically push, integrate, and deploy the code that you have done, up to having a fully released pipeline with a fully deployment pipeline implemented. Having continuous integration and continuous deployment will reduce the friction that happens when you do the usual integration. The idea is, if you have that automated pipeline that automatically does the integration every time you check in code, then the risk of having issues is extremely limited. If you check in 5 lines of code, I don't see many risk of integration problem. However, if you check 5,000 lines of code, the integration problems are way much higher. The risk of integration problems are way much higher. Having that pipeline built will optimize the resources that you're using, not just on the build process, but also on the deployment process. And it will allow to have a QA environment, a dev environment, a production environment with different variables, with different criteria and different settings. So it's the same source code, the same artifact that are going to be built and deployed into the QA environment, the dev and test. If something happens or something's wrong or broken into one of those environments, you can always block the deployment to production and roll back, fix the problem before you go and deploy a new version. It requires not just a build pipeline, not just the automation of the deployment, but it will require infrastructure as code. So you can actually have that deployment to be identical in the 3 environments. If your infrastructure is written as code, not only you're ensuring consistency into those 3 environments, but you're ensuring that your redeployment will be identical to the one you had before. You know that if you give the same documentation to 2 humans, there will be differences in 100% of the cases? There has been statistics done. I can give you a doc, and I can give you a doc, and the deployment will be done differently. Even though the doc is identical, there will be different discussion. So you will have issues at one point. There are some architectural decisions to be made or to be considered at that point around continuous deployment and continuous integration, which is how you deploy your solution. And the answer to that depends on the app depends on what you want to run, and it depends on what is your affinity in terms of technology from your company or from your team point of view. Continuous deployment can be deployed to virtual machines. Azure, in our case, would be the case with virtual machine infrastructure as a service. You would have to manage the configuration of the VM. You would have to manage the security of the VM, but it's an easy way to port the workload from on-premises to in the cloud. You can also make a decision to deploy to platform as a service. Azure websites, for example. The CI/CDPs will be easier. You will have the capacity to do auto recovery. You will have the ability to do tests in production. It's going to be easier to do scale out, but it limits to only websites. So that has a trade-off. And the last piece is the containers. Potentially, as we are now in 2017, you may want to consider containers and have scalable deployment of containers. You may want to orchestrate the deployment of containers to large-scale solutions, thinking of Service Fabric, Kubernetes clusters, or other type of clusters that you may have heard of. The decision of which kind of infrastructure you want to use for the deployment, again, will be a choice of you, your team, your company. I can just expose the different options and the capacity or the capabilities of each. I want to walk with you through CI, CD, and release management pipeline. So for that, I'm going to take a different app. The application is called Parts Unlimited. Parts Unlimited is an application that is coming from the Phoenix project. I hope everyone has read the Phoenix project. So it should be familiar, Parts Unlimited and Parts Unlimited MRP. So Parts Unlimited is the website, the e-commerce type of website, and we've actually implemented it. We worked to build the solution, the code. What I'm going to show you here is how we've done the build around this. So I have a code that is based on one single branch, not very advanced here. And I've done a build pipeline. Oops, it's not the one I wanted to show you. So you have a first build. So the build is going to do continuous integration on this piece of code. So first of all, I'm going to take the source code. And in my case, I'm using the source code from the same project. It's in VSCS. But I could use the code, or I could pull the code also from GitHub. If this is where you're actually currently hosting your code, you can get it from GitHub. What we're going to do is we're going to clone the code locally and run that code, build the code on our agent. It doesn't have to be public. It can be a private repo, and you would pull the code from GitHub as well. You've seen we also have Subversion and any other repo that is using Git. In the case of our pipeline, we've built a very simple one that has 3 steps. And I will walk through the different steps that you can add on the pipeline to give you an idea. In this case, the first step is to run a PowerShell script that will actually do the build in a scripted and automated manner. Then we're going to publish the results of that build so we can expose and see the result for each build on the test coverage. And finally, we're going to publish the artifact that this build process is going to generate. The artifact will then be reused into the release or the continuous deployment pipeline. So we can go and pull that iteration of the build into our code. If I can select it, come on. There it is. So running a PowerShell script, well, in that case, it's fairly simple. You just find the PowerShell script in your source code and run it with a bunch of arguments. In this case, I just passed the build configuration and the staging directory. This is the only parameters I need for my PowerShell script. You want to have your script into the source code, which evolves with the evolution you have of your code. So you change the code, you may change the build. That's that simple. Then publishing the test results. Currently, we're building it with XUnit, but you could use JUnit, you could use VS Test in case you're using VSTS or Visual Studio. So it depends on the format that you're using for those tests. You point to the test result file, the XML file, and that's all what you need to get the results pushed out. And finally, as I said, we're going to publish our artifact. So we are going to collect the artifacts from our staging directory. We get all the zip file, and we are going to archive them on that build. You may wonder where those $thing comes from. So VSTS, Visual Studio Online, allows you to have standard variables defined. So the build staging directory, the build ID, those are variables that are pre-configured and that the build will understand automatically, kind of. So those are variables that are defined by the build process. You can define your own variables. For example, you want to define the build configuration, or you want to put here secrets, like passwords. You don't want those passwords to be in the source code, so you want to pass them somehow. The somehow, and the right way to do it, would be to define them into the build definition, and that build definition will consume them. So that's a secret. So you see the little lock on the right-hand side, so you don't even see it. And then I would save and keep. I don't want to save the password here. So here is the connection with the source code that happens. So I'm going to enable here the CI, continuous integration, so that whenever code is going to be checked on my repository, based on criteria that I'm going to define, I'm going to launch this specific build. You may have multiple builds that are connected to the same source code, same source repository. Oops, that's a bug. So I said about the filter, you can include certain branches. So you're going to monitor certain branches for launching this build. You can also have filter based on the path. So you may not want to kick off a build every single time the documentation is being updated. That's potentially irrelevant. So you want to filter the documentation from that triggers. And you may also want to consider that if you have a lengthy build, let's say the build is going to take a day. Maybe you don't want to get all the builds that are being made or being launched during that day to also run each of them. So for example, you have a build that takes a day, and you have developers that are checking code every hour. So at the end of the day, technically you have 8 hours or 8 builds that needs to be run. So technically you're going to accumulate a certain number of builds and you're never going to catch up. So what you want to do, you want to batch those changes. So when you have a build that is running, you're going to stack all those changes and they will be run at one time. The other thing is, some organizations, some companies want to run the build. Some companies want to run the build at a certain time. Yes, I know. And you want to run that at specific times, at specific days of the week, for certain branches. So you can actually schedule those builds based on your timing. And that timing depends on your organization again, on your team organization or company organization. Now the options. There are some interesting options here. So for example, you and I would recommend to track all those things in the same environment. So if you have a build that fails for whatever reason, maybe you want to create a work item automatically. So your build doesn't go through. You create a work item so you can track what work is being done on the fixing of the build process itself. Or maybe it's just code that needs to be done and needs to fix the build. So it doesn't have to be fixing the build itself, but it may be just fixing the code that makes the build fail. Going back to having a full integrated work, plan, build processes, that's when you see the connection happening. The last one is the allow script to access OAuth token. That allows the authentication model to be used by the script that are run during the build process. So if you have the OAuth token, you may want to allow that to be used. And then comes the agent. So build needs to run on an agent. Let me show the list. So the agent is nothing else than just a simple piece of code that will run and do the job that you're asking that piece of code to be done. By default, you have a set of agents that are hosted on Azure, and your VSTS build will consume those agents. Those agents will run on a shared environment. They clean the code, they clean the environment, but it's a shared environment, so you have to wait until one agent is available. So basically, you launch a build, and the build will wait until an agent gets available. Then the agent will download the code, does a job, and report at the end of it. That is the hosted one. There is one constraint around the build agent that is hosted. That agent does not have the UI capability. It runs into a hosted environment that doesn't have UI. So if you're doing any test around Universal Windows app, for example, that's not going to be possible. In that case, you want to run the agent on a regular machine. So in my case, I have an agent that runs on my machine, so I can use that agent to run those tests. So run the agent will launch the Universal app, the Universal app will do the job on my local machine, and that's it. Now, on VSTS, you can run builds, or you can build applications that are not just Windows app. You may want to run and build apps that are Linux-based. So now you have the ability to use the hosted Linux agent. So we are hosting the agent for you, and you can use that agent for any Linux-based app. Or you can use the agent on macOS. If you want to do iOS app, for example. So I have a set of demos that are using Xamarin and building apps for iOS, pushing to the App Store. What I'm doing is I'm using my Mac agent, running my build on the Mac agent, and using the Mac agent to do the whole job and then push the code to the Apple Store. And finally, if you want to have an intermediary environment, you can launch a virtual machine in Azure, install the agent on that virtual machine in Azure or anywhere else, and then you have the agent running as if it would be running on a PC on your local desktop. You can have a pool of agents. So you're not restricted to one single agent. You can have dozens of agents. And you can say, okay, I want that a certain agent has certain characteristics. So I want that, that this agent has node. That node exists. Or you can ask all kind of capabilities for that agent. So if you have multiple agents, you may want to say, okay, I'm running on that pool, but I want to run this build on that pool, and I want to pick an agent that has this specific capacity. All right. So now that we have done the build definition, you can run it. Let's queue this build. So I'm going to go on a hosted agent, on the master branch. I have my system debug, no specific demands. Let's go and queue it. So it's initiating the connection to an agent. And here you get the logs that are returned from my agent running, and that one is running in Azure. So it's going to take some time to run. As we wait for that, I'm just going to go back to my build, the previous one. So before I do that, I wanted to show you that we can go in history and go back to all the previous builds that have been running for that specific build definition. You've seen I have a bunch of builds that failed, and the last one was successful. The 453 build was successful. So my success rate is not super good, but I can look at the last build. On the left-hand side, you see all the tasks that happen. So if something fails, it will show a red cross at the step that actually failed. So you can actually go back to your build definition and explore what happened. You can look at the logs at that time. You remember we had test coverage. We published the test results. The test results will appear over here, and you can pull all those tests. You can see that all of them, the 11 of them passed, so I have a 100% coverage result, a 100% pass result, and they run for 676 milliseconds. I can go into the detailed report of those test results. So if I had additional outcome, I would be able to get those outcomes over here and filter by pass, fail, and others. So you can see the test failures here. They're all good. And you can see the test durations for the different tests. So if you run many of them, you will have a bar graph happening, so you can actually drill down in history. And you can say, well, as an example, you can see that your test duration will increase over time, and that might not be the right thing if the number of tests remains. Or you may see an increase in number of tests, and that's good because you want to run more tests, but your duration will increase as well, and it might not be the thing you want to have. At one point, you may want to say, okay, that is a build I want to keep. This is the build we're going to make in production. This is our version 1.0, and we want to keep this one for a longer period of time. So you're going to retain that build over time in your build system. So you can always go back to that one, maybe have a deeper look at the logs, all kind of things like that. Going back to that one. So it's running. You see, it's at the step of running the PowerShell script. It did get the source. Now it's running the script. Takes about 4 or 5 minutes to run all of that and to publish the test results. At the speed of internet, of course. You are connected. While we wait for that script to finish, any questions on the build step itself? One question. Sure. Up, microphone's coming.
The build retain slide that you have there, can that trigger release pipelines?
That's actually the next thing I was going to talk about.
Okay.
The connection with the release pipeline is, and the answer to that one, the short one is no. The connection with the build, the release pipeline is not based on if you trigger the retain or not retain. You can actually do continuous deployment, which will actually go, after you've done the build, go to release and deploy those artifacts. Or you can say, I don't want to have continuous deployment, and what's going to happen is the build is going to push the artifact. When you launch a release, you will be able to select the version of your artifact you want to pull for that release. The retain will keep those artifacts more than the default, and by default we retain 10 builds. So if you want to go beyond those 10 builds, you want to keep a retain, and it will actually keep those. And there we go. It's easy when you already have the pipeline running, you know you've done it correctly. Just to show you one that failed, I always like to have one that failed. So for example, in this one, what failed was the published test result. And the message was the path was wrong, was too long, we couldn't find the XML file in the right location, so the whole build system failed, and then you go back to your definition and change it. I just wanted to go back to the build itself. And show you the different tasks you can add. So, by default, you have a certain number of tasks that are made available on the build pipeline. Some of them, I would say, are standards. They're like running a script, archiving files, making a copy, and those things. There are some that are not necessarily by default, and there are some you want to download from the marketplace. So all those extensions are either produced by Microsoft, by its partners, or by the community. And to be honest, I don't know all of them. So you can ask me any of those extensions that you want. Maybe they are already existing, or maybe not. I had one of my teammates who was doing some deployment with Kubernetes the other day. And he was like, wow, we don't have an extension for Kubernetes. So he took his Visual Studio and built a small extension for Kubernetes. And now we have an extension that goes from VSCS to deploy to Kubernetes. So it's pretty easy to actually build a task, a VSCS task, and publish it to the marketplace. And now it's being used. The one I wanted to show you, yeah, you have seen the Apple Store one. So you can actually build your iOS app and publish to the Apple Store. Obviously, it's kind of expected, but you can deploy to Azure. We'll walk through that in a minute. You can run a PowerShell script. You've seen it. You can deploy your resource, Azure Resource Group. You can deploy a database using a DAC pack. One thing that is new and is very interesting is to bake an immutable virtual machine image using Packer, and that will be used in case you want to deploy to VM scale sets. So VM scale sets is the copy-paste or identical copy-paste of a virtual machine. So think of it. You have an app, you deploy that app on a virtual machine, and you want to have that environment that can be cloned as many times as you want. So you can either do it yourself, or in Azure, you can use virtual machine scale sets. And those virtual machine scale sets will automatically scale out based on the load of the initial virtual machine that you have deployed. It will also manage the load balancer that goes in front of that, so you don't have to redo the networking piece. It will be done automatically for you. But to get there, you need to create an image. And the image, there is a tool called Packer, for those who are not familiar with it. Packer will actually create the image, install the app on the virtual machine, and generalize the machine in case of Windows, or remove what it needs to be removed on a Linux machine. That image, once being generalized, can be duplicated, cloned, as many times as you want before being used in the scale set. That's still in preview, but it's an interesting solution here to be able to scale out, getting the capacity of the cloud without having the burden of creating the networking and the load balancer and all of that. We have a JMeter load test, you have a cloud-based load test, and a cloud-based web performance test. So you can run all those tests when you do your build. So you can say, well, I'm going to do a build, I'm going to deploy that temporary build to a dev environment, and on this dev environment, I'm going to run a certain load test before I actually move to a QA or staging environment. Then you have CMake, CocoaPods, then you have the utility copy files, SSH, SCP. You have curl, deployed to Apache Tomcat. You have all the Docker compose, Docker build, Docker deploy task in case you're deploying for a Docker container. And this container can go to Docker Hub, or it can go to Azure Container Registry. Azure Container Registry is the Docker Hub for your private environment. So you don't have to go to the public Docker Hub to deploy your containers. You can publish them to Azure Container Registry and then restrict who can access that container registry in your environment. You have Gradle, Grunt, and Glump. Try to say that. We'll talk again. OKApp. OKApp is an interesting solution for mobile dev. So if you're building mobile app, OKApp is a way to do kind of a staging environment. I would say you actually deploy your app to a Hockey app. And then you can distribute this app to a certain number of beta testers before you go to a more broader scale type of deployment, which are offered by the stores, regardless if it's Google, Apple, or Microsoft. OK app is totally disconnected. So you download the artifact on your phone, on your tablet, and run that beta version of the app before it actually can even go to the store. You have the Jenkins download artifact, the Jenkins queue, the JFrog Artifactory connection that also exists over here. The Kubernetes tasks I was talking about, which actually connect and deploy artifact to Kubernetes if you have a Kubernetes cluster. Maven, of course, we had Gradle, so we're expecting to see Maven. That's kind of usual. And then you have the usual NuGet package installer and package manager, so you actually can manage your packet and restore your package when you build an app. Fun things like post to Slack. So you can say, well, when my build is done, I want to post the result of my build to Slack so my team knows about it. So you don't have to go to VSTS to know what has been the result of the build. It goes directly to the Slack channel, so everyone is aware of it. That's an interesting one. So if in your environment you have a file that has a token, or in your code you can put tokens, and you use that task to replace the tokens in your code before you do the build. So it could be anything. In configuration file, place the token with a regex, with a value that comes from the environment that you use for the build. It works very much with anything. So in your text, it reads a text file, and you would say, here's what I want, and you put the regex expression that you want, and I want to replace that regex expression with this value. So it could be in a JSON, could be in text, could be a YAML file, and it will actually put that variable in the file itself on the agent, and the agent will actually see the final value instead of the artifact, instead of the regex. What else? SonarQube, which is deprecated, so I would be careful here. Service Fabric. This one is also interesting when you want to version your assemblies. I would highly recommend to use that extension, the version assemblies by Colin. I don't know if you know Colin Dembowski. He is an ALM Ranger. He has built that extension, and it's extremely useful. Then you have the different builds and the connection with Xamarin and Xcode. Just a browse of all the extensions that I have on my environment, which I use very frequently. And then, as I said, you have the marketplace that has all the other extensions. Now, let's go back to my build. Now let's say you want to go one step further. And you want to go from pure continuous integration to CI/CD and have the deployment going with it. You can actually reuse the existing build, or you can create a clone of your build. That's usually what I do. I do get my existing build and clone it. The clone will just really make a copy, and then you can reuse it, modify it. And the only difference I have here between my CI and CD is the last step, which is to publish with my artifact my ARM template. So in this case, what I want to do is I want to publish the artifact that I have built on an Azure website. So I'm going to go through the whole deployment of going to websites and virtual machines. So for that, I need an ARM template. So my ARM template is a JSON file that defines my infrastructure as code. And I want to ensure that my release will be able to read those files. So I'm just adding this ARM template into my, my result. And now let's move to release. Up, eventually. Here we go. So, for my release environment, I've created 3 environments: dev, staging, and production. For each of those environments, and you have to think of those environments as just a virtual representation on how it's going to be in real life. You can create as many environments as you want. So I can clone my selected environment. I will come to that in a minute, but so I'm creating a copy of dev, and it could be dev2, or it can be perf test. So you basically name them as you want. You can reorganize it. For each of those environments, you define the tasks that you want to run in those environments, or you want to run to get to those environments. In my case, what I want to do, I want to deploy those artifacts to Azure. So what I've done, first step is to deploy my environment using the Azure Resource Manager template. So to do that, I'm adding the Azure Resource Manager template deployment, so this one, Azure Resource Group deployment. And that tasks is going to deploy, create and deploy my base environment in Azure. I'm coming to this point in a sec. But here, you define the subscription you want to use. So that's some of the housekeeping that I've done beforehand. I've integrated my VSTS environment with Azure. And for the technical details, I've basically made an SPN. It actually does an SPN and connects the VSTS to Azure, so VSTS has access to Azure without knowing your username and password. And the user who is going to do the build will not have access to all those secrets. It will just say, I want to run on this subscription. And that's it. Because you've allowed that subscription to be accessed by the VSTS environment. So what I want to do? I want to create a resource group where I will deploy some resources. Resources will include virtual machines, websites, SQL database, all of that. You see, you can actually start a virtual machine, you can delete a virtual machine, you can also delete resource group. Then I would have to give the name of the resource group. And that resource group can be something I enter here, like this. Or you remember, we can use variables. So it would be $, my resource group. And in the variables, I will have to put the name of my variable and the value of the variable. Then you have to define the location. So we can take, in that case, we would take West Europe, North Europe. And finally, which template do you want to deploy? You remember in the build in CI/CD, we've actually exported the ARM template as an artifact, which means that if I go to my list of templates, my list of artifacts, I see my templates, or the different templates I've been using, and I can use this one. So when I do the build, the result of the build will be pushed as an artifact, and I can consume the result of that into my Azure deployment. For the parameters of that template, you can also use a JSON file which has all the parameters and all their values. Or you can also override those parameters with a command line here. Let me show you the one I had before. So you see in my case, I override the name of the template, the website name, with the value that comes from the website name variable. So whatever is in the template is good, but then for some secrets, some stuff like that, password and so on, I want to override those at build time. So you can have a different environment for dev, QA, and so on. The last piece I wanted to show here is the deployment mode. When you were deploying to Azure with a resource manager template, you can select one of those three options. When you do an incremental deployment, only the resources that do not exist will be created. So you have a virtual machine that already exists, you have a website that already exists, they will be updated. But if you have an object, let's say a SQL database, that exists and is not described in the ARM template, the deployment will not touch those. If you select complete, what is described into the template will be actually what is deployed, which means in your template, if you have a website and a virtual machine, but not that SQL database, that SQL database will be destroyed at the deployment. So you want to be careful on which model of deployment you select here. Then I'm going to add a website to this environment. So what I'm deploying is a bunch of resources, virtual machine, SQL database, and a website. And then I'm deploying in this website the artifacts that I've built before, and I'm deploying them to my dev slot. So I'm going to have a website that has multiple slots. In this case, I'm using the dev one, but I could use a different name if I wanted. I could use them lip dev. I'm going to remove this one. All right. Then I'm going to do the same thing for the staging environment. But for the case of staging, I already have the virtual machine, I already have most of the resources there. So the only thing I need to do is create a new deployment for my staging environment. So I'm going to just do a new slot called leap staging, and I've basically copy-paste the one before. And finally, I'm going to create an environment that is called production. And that production is not using a slot. I'm actually deploying to the real website. So I have like 2 steps in slot before I actually deploy to production. I'm saving that release definition. I'm going to link that release definition to my build. This is where we make the magic on how the release knows which binaries to take and how to deploy them. So when you do the link of the artifact source, that's when you say, well, I want the source from build. I could use them from Jenkins. If you're using Jenkins today to do build, that's fine. Or Git, or GitHub. So if you have a Jenkins environment, you just connect. You need to actually be connected, so you need the authentication. I don't have a Jenkins environment here. But then you would do the connection to the service, and you would connect to the job itself. So you would point to the job, and it will read the artifact from that job to build those elements into the release pipeline. Sorry. Here, we connect to a project, and we're defining which build definition we want to use. So I'm going to use the CI/CD, which is the one that is going to produce the artifact. You see that in this environment, I have actually several build definitions. So I can go to one of the other builds and aggregate the artifact from 2 different builds to do my release. Then I can select which version I want to use as the source for my release. And I can be very unspecific and say, I want the latest. Regardless, I'm taking the latest version of those. Or you can filter by tag. So I can say, well, I want the one coming from a version of a branch with a certain tag. So if you do your build, tag that build with dev, then those are going to be the artifacts that are going to be deployed into dev environment, nothing else. And if you deploy to release, or you build for release, then you can say, those who are tagged by release will go to a release environment, and you still have your deployment mechanism or release mechanism for release. So I have my source alias done. And now here's the trigger. So the trigger is how I'm going to go automatically from build to release. That's the continuous deployment. You connect to the artifact, the source that we have just done. And if you have selected multiple branch, you can actually be very specific on which branch you want to use for continuous deployment. And you can also add tags over there. You can also filter and have a schedule for the continuous deployment. So you may want to say, I'm building every day, 5 times a day, or 10 times a day, or 100 times a day. However, the deployment in dev will happen every night at 10 p.m. Or it will happen at 5 a.m. because those who work late still have the opportunity to deploy. That's, again, your company policy here. So, now that we have our environment done, let's go and create a new release. So that should happen automatically, right? But you can force it manually. Or you know what? Let's go to my build and kick off a build CI/CD. So we go through the full pipeline, the full build, and then we go through the release. I'm going to walk through the release when they happen, as we let that go through in the backend. Here, you have a summary of my release, and you remember we have those 3 steps: dev, QA, dev, staging, and prod. So for each release definition that you make, you see a summary of those environments, how they look like. Is it green, blue, you will see the blue in a minute, or red? Red is basically meaning failing, green is okay, and blue means in process. Sometimes you have a little extra, like a little clock, which means it's pending for user's approval. Let me show you what user approval means. When you go from dev to staging, what you've seen so far is how you enter in dev, which is continuous deployment. But once you enter in dev, how do you go to the next step? How do you control what's going to happen? How do you control how you go from dev to QA? Automatically? Do you need someone to approve? Yes, no, maybe? So what you want to do here is to assign approvers. And let me go to production, that's going to be more relevant. So the approvers are people who will be notified to say, I'm okay with that deployment to start, and they will be also approvers of the post-deployment. So you can have different people that do, okay, let's go, and people who say, okay, that looks good. You can also say it's automatic. So I don't want to control who is going to go and approve the pre-deployment, or I don't want to see anyone approving afterwards. You can have multiple users. And you want to have all of them to approve before you go to the next step. So when you go to production, the pre-production approval can be, let's say, 3 people, and all of the 3 have to be approved before you go to the next stage. Or you can say, well, just 1 is enough, they're good to go, and we'll go. In terms of auditing and compliance, that can help you from preventing things, or actually, for the compliance, it will track those records, so you can actually go back in history and measure who has approved which release at which date and which time. And the last piece that is interesting is here. You cannot be the one that created the release and approved it. So if you're a single person demo, you don't want to check that box, or your release is going to be blocked. So we should soon be into the release. No, the agent has not finished its tasks. Still in progress. Okay. To see where it is. It's running a PowerShell script, so it should be done very soon. Yep. While we wait for the agent to go through, any questions? Yes.
Yes. With approval of the release, do you have any kind of control of the timeline? I'm thinking usually we have some kind of manual verification when something is in production, And the question is, if you have several approvers and one of them don't approve before 5 hours later and everybody went home, will it then just deploy, or do you have any control over that?
At this time, we don't have this control. It's a feedback I've heard several times, and I've brought it back to the team that is working on this. I don't know exactly what is the priority they're putting on this, but it's a feature that I've reported.
Yeah, okay. That sounds something we would need at least.
Yeah, I know. Many customers are asking for it. You're not the only one. I would say, unfortunately, for us. I have one question over here. Yeah.
Our team has a definition of done, saying that you should build and test it with a GUI and not just reading the code before it gets approved. But is there any practical way to deploy from a feature branch to a totally new environment if you not want to push it to develop environment?
You could actually, that's what you could do here. You could define the release to go from a feature branch. So in the case, let's see here, I would create a new release definition, but let's say this is a new one. I can change it. But I would go for from a source, has a build definition, and I would point to that feature branch specifically. So I would create like a specific release that says feature branch release, and I would go from that source. Now all the feature branch will have a different name potentially, so that will create an issue because you are tagging to a specific branch, and the name has to be specific. So I would rather use tags on the release artifact to go rather than the branch itself. I would say, okay, any branch, but with that tag will be considered as the source for my release. That's the way I would look for it. And I would have a specific release pipeline for that. Yeah, I would go that route, if that answers. Good. Thanks. Everyone is anxious to see how my release went. Oops, something went wrong. That would be a good exercise for lunch. Unable to retrieve connection details for Azure App Service. I don't think, well, I hope Azure is not down. I think it's more like variable definition PULTD core. Okay. It's in the app service deploy. Let's go to the environment. Oh yeah, I changed the slot name. And the variables, I should remove that one. All right. Let's try to redeploy that. Oh, and one thing that that's interesting, when you have a release going on, you can abandon the release if this is not the case. So in my case, it's not the good one. Let's create a new release. That's where you select the build, by the way. If you have multiple builds, you can select the build number you want. Is it the right one? 476, yes. logs. So same thing here. The release pipeline will use an agent. The agent can be a hosted agent, it's actually the same agent that we build, so it's using the same capabilities. In my case, I'm running in Azure, and it found one. And let's see, fingers crossed. I will know in a couple of seconds if I go for lunch or if I debug things during lunch. The dramatic music. I've been playing a bit with this environment last week. I may have broken something. So basically, it's actually going to, again, deploying to Azure. I will show you the Azure deployment as we wait for that. So I'm actually deploying everything in this resource group. And as you can see, the resource group has a bunch of things. It has an application service. It has a set of, it has a set of database. My different website environment, which I'm using for the deployment. And we'll talk about that after lunch, but it's application insights, which allows to monitor and control what's going on into the application with more details. So that's how we understand how the application, the web application run, and what is being used, or how each of the lines of code on the application is performing on this specific website. Okay. I have to troubleshoot that during lunch, I guess. But yeah, basically it's the idea. All right. Do you have any questions? We're like 5 minutes before lunch, so yeah.
Wait a second.
Oh, sorry.
Yeah, it's more from an operation perspective. If you deploy to this dev environment and the staging environment, and something unexpected happened in the production environment, how do you recover? Do you redeploy the older version if that doesn't work? How about the backup routines? And yeah.
So from the operation point of view, if something happened in production, how would you redeploy in production, for example?
If you have database change, yeah.
So the management of data is always an issue because, of course, you have data that evolves. I would say there is not a simple answer to that. What you want to do, or what you may want to do, is separate the compute to the data management. So they are in two different entities, and usually that would be two different resource groups. So you keep the data separated from your front end, your websites, which means that they have different life cycles. And that's how you want to think about it. You want to think of your application, or the different component of your application, with their specific life cycles. So in the case of how do you recover in case of problems, and you have your data and your front end, well, I would say the right approach, and actually this is what we're doing here, if you look at the release, the data in the database are deployed during the first phase, and then dev and QA, staging, and production are in 2 different phases, but we don't redeploy the database. They just have different connection string to different databases. So let me show you what I'm saying here. The production environment, where is it? It's in the, oh no, it's somewhere else, okay. So you would just change here in the environment. Sorry, staging. Let me find it. So you can define variables. I think it was on this one. Anyway, so you can define variables, and those variables will actually be applied to the environment when you deploy. So for example, in production, you would have a connection string that will be different than the connection string into dev, and it will point to different database. Coming back to your point, if you keep the production database separated from the dev database, you just redeploy the latest version or the N-1 version of the website to the production. The database hasn't changed. Does that make sense?
Yeah, sort of. But yeah, if you have made a change, you have to separate the packages, maybe the transitions.
You would have to separate the packages.
Yeah.
And the other thing you have to be careful, and that's a topic we are touching a bit later in the afternoon, is the feature flag deployment. So usually when you do changes in the schema of a database, for example, you want to be careful on those deployments, and you gradually roll out the deployments. Now, that being said, there is no magic. You've changed the database schema, it's there, and you have to kind of cope with it. Which comes back to the importance of having all those testings, unit testing, UI testing, load testing beforehand, and having them automated so there is no way you can bypass that step. But yeah, it's dangerous to do a rollback, and in a DevOps time of terminology, you usually prefer to have a roll forward. So when you have an issue, you identify the problem and you redeploy the next iteration, which is potentially coming back in terms of architecture, but you don't redeploy your previous version, you just deploy your next version and you iterate on the...
Yeah, so just fix it with the next version then, migration script or something.
Yes.
Yeah. Thank you.
Thanks. Good. I think we're good for lunch, and I'm good for debugging. I'll have a look at this. So we have an hour for lunch, if I'm right, and we are back at 1 o'clock. So good. I don't know where we go for lunch, so I'm totally relying on my local team.
We will follow Inger. The restaurant is at the other side of the stadium, so we'll just walk inside. It's a pretty cool place, so you will enjoy it, I think. So yeah, I don't know if you want to go to the bathroom first, and we can start in 5 minutes. Is it okay? Yeah?
There will be people here, so you can leave your stuff.
Yeah, the room will be locked, so you can just leave your stuff. if you are ready, please just follow so you don't get lost.
So please take your seats, ladies and gentlemen. Inn der, bak, eller forbi livskiltet, så ser du der borte.
Should we give a couple more minutes for everyone to come and join? No, we're good? So, I hope you had a good lunch. I feel refreshed and ready to go for a full afternoon. Before we start, I would like to give kudos to the gentleman who helped me fixing the build. I'm just looking for him somewhere. Someone helped me to fix the build before lunch. Oh yeah, so thank you, it worked. I indeed had made a mistake and it was identified, so congratulations. I don't think we have any goodies or, I'm looking at Pedro. Ah, but you deserve one. I'm sure they will figure out something to... All right, good. So before we start again and going through a bit more the release and all of that, anyone has any questions on what we have done this morning? And I know I should go in the front light. Sorry for those online. Anyone has any questions on what we've seen this morning, what we talked about this morning, anything that prevents you from sleeping and digesting nicely?
Yeah, I have a follow-up on the use of the, when you set up the development, staging, and production environment and using web apps, on how you use slots.
Yes.
I asked this in Redmond as well, and I feel that using slots, you can basically define dev environment and test environment as a slot. I don't think that would be the right way to do it, but I saw that you didn't switch slots or swap slots when you push to production. I don't know, just in general, if you have something more to add on how the best way to do that is.
So regarding the slots, yes, I haven't, and we haven't touched the swapping slots or things like that. The use we're doing on slots in this approach is more, we deploy to different environment, and yes, switching or swapping slots is another approach you can use on the website, on Azure websites. I prefer to redeploy to environment, considering that we want to leverage the capabilities of VSTS. Now, if you only have one pipeline that deploys to a certain slot, then you can use the swap to go from dev to prod. That's another option. I would say either are valid. I cannot say there is a better or worse approach. They're both valid and they both stand. In that scenario, when we go into other capabilities like like testing in production or scenarios like that we'll see later in the afternoon or this afternoon. Excuse me. The fact that we have that you have slots will allow you to inject another version of your website into an existing environment, and you do like you reroute a certain percentage of the traffic on a slot and another percentage on another slot. So that's another capability you can use from the slots point of view, which is more difficult in production.
Thank you.
But that's pretty much my my only message around this, I would say. Good. All right. Okay. So, monitor and learning. Monitor and learn is another practice that is highly important when you do DevOps. So far, we've seen how you build, deploy. But once you've deployed, if you want to continue the circle and you want to make sure you continue to close the loop, you need to understand how your application is being used. Not only how the application is being used, but also what are the challenges that are being faced when the application runs, which are the bugs, which are the crashes that the application will face. And not only with the crashes, but also the performance of the app. So when we talk about monitoring, there are few types of monitoring. One of them is the availability monitoring. So the availability is the thing that you measure, is like, hey, is my service up? Is it running? I would say it's the standard thing. And you want to measure that in a way that helps you to collect the result even before you get users calling your help desk or users calling your service center, because when you start having those issues, you want to be able to address as fast as you can. The other one is the application performance monitoring. Application performance monitoring is the philosophy of, I have my system running in production, I have users consuming it, but I also want to be alerted when my service is not performing at the threshold that I have defined. If you're running a website that is an e-commerce website, for example, and your checkout process takes, I don't know, 2 minutes. When you click purchase, you put your credit card, and then it takes 2 minutes to think about what it's going to do. What do you think the users will do? They will run away. They will not purchase again. So the performance of the website is an important criteria to consider from a business point of view when you, for example, run a website. I was talking with a person from an airline company, and that person was telling me that they made statistics or analysis, and more than 70% of their customers will only have an interaction with that company through a mobile app or a website before they actually board the plane. So people will make an assumption on how the airline is based on the website and the experience they have on the website. So they want to ensure that this experience is as good as possible, because that's really a trigger that will define purchase decisions from customers. So performance is an important topic, and it will not only help identify problems that can be code written in a certain way that has latency, it can also be problems into how the code is being wired, but it can also identify the usage of resources or bad usage of resources. Thinking of you've deployed a website and you're reaching the capacity of that environment, then you may want to scale up, or you may want to scale out, depending on which kind of scaling you want to do. Talking of testing and scaling out and scaling up, it's important to also do the load testing and get the learnings from that load testing. So the principle of load testing, and it works pretty well in Azure. I talked about it this morning around VM scale set. It works also very well on websites. The ability to identify when you run into a threshold or a bottleneck and scale out your application environment with X number of instances, the number of instances depending on the capacity that is needed is an important criteria. So you reach 80% compute processing over 5 minutes, you want to scale out and kick off a new instance of that website. On the website, you will define number of instances or number of cores that you want to use, and it will be going up and down to a certain limit. So you can define the limits you want to maintain that capacity or that quality of application. And finally, the user telemetry. So the user telemetry is the philosophy of having a system in production and you measure what's happening over time on that system. The telemetry is pretty much now something that is implemented in every solution, every piece of code that you install. I can take the Microsoft examples. When you install Windows, for example, you just have the ability to report some usage info to Microsoft. They're totally anonymized. If you do Visual Studio, you will use the same thing. If you do Office, you will also have that telemetry. But the telemetry is also into websites. Amazon, for example, is also tracking the path and the amount of click it takes for a user to go from visualizing an object to buying it. They have an extremely interesting business intelligence being done on the path and the tracks you're doing on their website. On Visual Studio, I was talking earlier today, we also identify what is the experience of our users when they launch Visual Studio. Just to give you an example, if you've installed Visual Studio 2017, if you have not done it so far, I will tell you what's happening. When you open a solution, Visual Studio 2017 will give you the impression that it's actually up and running faster than 2015 by restoring the packages and all of that under the hood. So in 2015, it was on the UI. You were looking and it was restoring everything in front of you. So you could see, well, it's struggling, it's doing a bunch of things, and it's taking some time. 2017, that's totally hidden. You don't even see it. And it gives you the impression, it doesn't mean it's taking more time. It gives you the impression that it actually goes faster because it gives you the hand at a faster speed. That's one of the learnings we have collected through telemetry. So that telemetry is extremely important. And not only it gives how people are reacting to a certain configuration, but it also gives you what are the features that you want to invest into to make customers more happy with your product or your service or your website. And it also measures the user activity, if users are using it or not. So, let's walk a bit through telemetry and see how that works. So I'm going back to my application, the parts unlimited. So, for the telemetry, with Azure, we are going to use Application Insights. So Application Insights is a resource that you can deploy anywhere. You don't really have to be in the same environment that where you are, so you can deploy Application Insights in East US and have your resources in Northern Europe. That's totally fine. Application Insights will collect the info from the websites, will aggregate those data, collect those data, store them, and allow you to actually analyze the data, the usage of the website or the application that you're deploying. So it all starts with the code. That's where things start. So let me find the code. So in my application, the parts unlimited. In the website. I just need to find where we put it. So you have a key that comes from Application Insight. Oh, I should have started by the key first. So we're going to log the data into the Dev Insights Application Insight resource. So for my dev environment, I have an instrumentation key. And every Application Insight environment that you're creating has a specific instrumentation key. So that key is pretty much unique, and that's how it's identified by the application on where to inject the data. Then that instrumentation key must be stored into the code. And I'm just looking, I don't remember exactly where we put it. Here it is. In your config file, you simply define Application Insight instrumentation key, and you refer to your instrumentation key that you have copied from Application Insight. So far, so good. Pretty simple. So now that you have done that, in the Application Insight itself, you have, hold on, I think I'm not looking at the right one. Do I have the right instrumentation key? 241. Yep, we're on the right one. Okay, good. So for Application Insight, you can browse on the with different perspective. So you can measure the usage based on number of users, sessions, and all of that. You can also have a certain set of events. Depending on the version of the SDK, you could do live metrics, so you can actually stream the data live. And you can have performance info. As you can see right now, we don't have much data. Those are the ones that from the last 24 hours. So we should create a bit of data on my application. So we should go to that application and get some data running. So that's my telemetry. And I should deploy that into production. So I'm deploying this in production. And we are going to go to the website. So the website is my dev. You usually don't do telemetry on production. When you could do in production, but in that case, I just put it into dev. And it's not deployed yet. So just give me a second, it's going to be there. We can look at the data from a couple of days ago. So here in this example, for example, I'm looking at the server response time, number of requests, and dependency duration. So that was from last week. So if you want to look at the performance more specifically, sorry. Sorry, the usage. But I'm looking at the one from last week. So we're going to expect a different time range. There we go. So those are the data that comes from when I prepared for that session. So you have an estimate of number of users, number of sessions, number of page views for the time that you have identified in a time range. So in that case, I had total number of users, 5. Number of sessions, 10. Number of page views, 33. Now, what you can do here, you can actually filter and identify where the users come from. So if you select the users, in my case, it was very easy. I was in the office and I was doing the test from home. So they are all coming from the United States. But if you have a distributed web app that runs across the globe, you may want to see that your application that has been deployed in Northern Europe may have 20% of the application, of the users coming from North America. And maybe you want to think of redeploying an instance of this application into a region that is closer to them.
You just said that you usually would use telemetry in production. Was that, did you mean that? Because this is production.
No, I mean, we should use telemetry in production. It was a mistake in what I said. I had a thread that was dumping at that time, I guess. No, you want to use it in production. So yeah, you can even get deeper into the region. And then you can look at what people have been doing. So the number of requests, the custom event, the page views. So you can filter by that kind of things. That gives a lot of insights of what's happening on this web app. What I wanted to show you too is on this instrumentation, in the performance, so if you go to performance, you have a slightly different view, including the server response time, as I said, and the dependency duration. What you also get here is the amount of time it takes for each operation, the number of requests you get for each operation, the median milliseconds, and the 95th percentile in terms of milliseconds. So the median is what is the average? Not the average, but the medium. So if you take the highest and the lowest number, what would be the medium between the highest and lowest number for the load of that operation? The 99th percentile is what is the value under which 95% of the operation will be executed. So if you take the index page, 95% of the index page has been loaded in less than 15,758 milliseconds. Now, if you want to search through that, you may want to order it by this number. And you want to get the highest one. What is the time range here? Sorry, I was looking at the wrong one. Because I've introduced a bug into the dev environment. And I want to show you that one. There we go. So in the dev environment, if you sort by the 99th percentile, the first page is interesting, it should report more, less than that, but anyway. You see that the second load, that is the highest one, is the home recommendations. That goes to 70 seconds for loading a page. That's quite high. So usually it's not, it's something you want to investigate a bit further. You want to understand what's happening there. You want to go into more details. So if you click on that one, you see that there has been one single request. And you can more details on that request. Yes?
In Google Analytics, you can add parameters, customize parameters for measuring. It will be the same here.
What does parameter reports?
A sample can be if you have a web shop. It can mean that maybe you want to. When you go to a page, you not only will have the page, but you also will have some value from the page into this measuring system.
Like
amount, what you want to buy, and how much you want to buy, and in Google Analytics you will be able to add these to the parameters. So when you send this for measuring, you can later go back to the system, and in the report you can see what you have measured. It can be interesting to see there maybe some places will buy more than other places.
Yes, you can do it. I haven't implemented something like that, but you can actually do it into the application, in the code. And that will be reported into into the custom data. So that would be exactly in that place where you would have it. So in that case, you get, that specific request gets more details. And then you can look into the related things. And here's the exact request that has been asked, the code, the response time. And what I wanted to show you here is that for this item, as you're browsing through the requests that are coming on the telemetry side, you can create a work item. Those work items will go to your VSTS Kanban, and then they can be assigned to a team to be worked on. So I'm creating my new work item. It's an issue with get home recommendations. The area, that's automatically populated, but you can change it at creation time. The type of problem is a bug. I'm not assigning to anyone. and it brings some kind of data. Then I just validate the creation of the work item. Now if I go back to my VSTS environment, to my work, then I'm going to run a query. So one other thing I didn't show you this morning is in the work you can actually run queries. You don't have to go through the user stories or the existing plan that you have, but you can also create your own query. So in my case, I'm just doing a query based on the bugs that are open. And here we go. That one that has been just created a minute ago. You can see all the details that are required from the operations point of view, including the location, the website. You have the device type, if it's a PC, a tablet, or anything like that. You even have the SDK version, kind of things. And you can actually connect back to the portal. And if you have the proper permissions, of course, it will actually open directly the performance that I was showing you into Application Insights, the performance issue that I was showing you in Application Insights. So if you're a developer, you have that, you want additional details, you want to dig deeper into the problem, then you go to the portal and dig into that sequential sequence of items. Then you recover and you see all the things that we talked about this morning, the feature branch and all of those things. Do you have any questions on this? Or pretty straightforward for everyone? Application insights or telemetry? Yes. Up, Mike's coming. But the question was, do we have any plans to have that for desktop applications?
VPF, desktop applications, you have to write everything with the custom metrics and stuff like that, and hooks for buttons and tabs and stuff like that. It can be done, we did it, but does it come with more support in the SDK, so you don't have to write everything yourself?
To my knowledge, and I'm looking at Pedro because I'm not very knowledgeable in that area, but I don't think we have anything coming up in that area.
No. Okay. So application insights in your WPF applications, they will track your exceptions, but they won't, of course, handle the paging that you can see on the web application. So you actually have to add custom telemetry to that. But having said that, it's very easy to create an attribute and just attribute the classes to have that kind of usage monitored. So it's super easy.
All right. So, so the next topic I wanted to demonstrate or walk through with you today is what we call testing in production. So we're going to take that app that we have deployed, and let me close a bit of the windows. So we're going to take that app and do some testing in production see how the app will react to different configuration, different environment into production. So for that, I'm going to clean up a bit the environment. That one I can close. All right. We have a cleaner environment. Okay. So for this, we're going to start with Azure, and I'm going to my resource group. Let's make sure that we have deployed the full app before I go somewhere else. Telemetry has been deployed. Okay. Just want to make sure that we have a good running environment. It's going to do it itself. Perfect. So, so in this environment, I'm going to take, reminding of you, we have deployed a configuration, a resource group that has a web app with 2 slots, staging and dev, a certain set of database, and application insights that are configured to this, connected to this environment, to this app. So I'm going to take my application service, my web app, and I'm going to verify that I can access it. So that's our app, basically. I'm not going to work through the app, but just to show you how the application looked like. That's our core app running currently on Parts Unlimited core Azure websites.net. So now what I'm going to do, I'm going to do some testing in production. So what we're going to do, we create a new slot, and we're going to do an investigation on having different versions of the app running under the same name. So for that, I'm going to the deployment slots. So I have the staging and the dev running. What I'm going to do, I'm going to add a new slot, name it test. So we're going to do that test. And I'm going to clone it from my core environment. There we go. So I've just created a new slot. And I'm going to go to Visual Studio. Sorry, forgot to clone it. And I'm going to deploy to the test a different version of my app. Going to take a second. So, as you have seen on the website, we have a carousel that starts at the beginning, and the page turns every about 5 seconds, roughly. So what we're going to do, we're going to deploy a new version of the website that instead of running every 5 seconds for the carousel, will run every 20 seconds. So I'm going to edit that page and make a version that runs every 20 seconds, and then we'll try to run on the 20 seconds. So on the carousel, let me make sure I'm the right page. Website. Yep, we're on the right one. So I want to add the interval. And I'm going to make 20 seconds, so that's going to be 20,000. So now I'm going to publish this one. And you realize that in Visual Studio, I can deploy directly to the web app. So I'm going to look for my web app. Here it is. So I'm directly deploying to my test deployment slot. It's going to take a second or two to deploy. And what we're going to do after that, we're going to go from my website, we're going to route 99% of the traffic on one slot and 1% of the traffic on another slot. And then from the measurement point of view, from the telemetry point of view, we can control and measure which website, which version of the website has been more successful. So while Visual Studio is publishing to the test slot, it's almost done. We're going to switch back to Azure and reconfigure the Azure environment to do that deployment. Almost there. So I'm just verifying that we actually have a good deployment of of the test app. And it seems to run every 20 seconds. Carousel is not moving. It's going to be 20 seconds. It's very long when you wait 20 seconds like that. And there we go. Okay, so we have a 20-second version here on test. Now, going to my website where I have created the test slot. I'm going to go to testing in production. So I'm going to select test slot. And let's say test is going to go 99%. Oops, no percent. 99%. And production, staging, is the one, oh, sorry, we have it. Let me get out of there. Ah. Sometimes I like the interface of Azure. So we said testing in production. So currently, just want to show you, currently 100% of the traffic goes to the production slot or the production environment. We are going to add the test, and because we want to measure if test is working, we're going to add 99% of test, 99% of the traffic that goes to the production website will be rerouted to the test slot under the same URL. Good. So if we go to the web interface, to the URL, which version do we have? The 20-second version. Note that the URL on top of it doesn't have the dash test, which is the deployment slot under test. So that is actually an, I would say, abstraction from the production website to the test slot, so we can actually measure how that test environment really behaves in production in real life. So you're testing in production. Users will not see a difference. You are the only one who actually know that you're testing two different versions. And 1% of the traffic will go to the normal version in this case. Any questions? Testing in production. Yes, one question over here. Okay, and I will repeat.
So when you know how the 1% go into the other one, how do you in app inside do you see now that there is a person coming from the production URL to the other one so that you can, how do you analyze the result?
So the question is, how do we analyze the result through that testing in production? So you remember that we put a key in the code that makes the connection between the code of the website and the application inside entity. So because we've duplicated the production environment into the test slot, that same version of the GUID will be into the test environment. Now, That being said, so it will pull all the data into the same application insight environment. Now, in the application insight environment, you will want to identify or tag the requests saying that that comes from the test environment or that comes from the production environment. And that's through the additional code you're writing that you want to measure those things. If you don't change anything, it will just go to the same environment and you will not have a differentiation point. So to say it differently, to be able to know if it comes from test or not, you would have to add a tag into the measurements you're doing for that version of the website. There will not be a magic. There is, it's not magic. Mm-hmm. We have 5 more minutes before the coffee break. Or not. I wanted to give 5 more minutes for questions, but that's pretty much where we are with test in production and telemetry. What else I wanted to say? On the telemetry piece, I mentioned briefly the live streaming. I want to talk about that. So it's called live metric stream. It's an interesting concept that actually gives you all the details, all the info in real time. However, it requires the latest version of the SDK, the 2.something version, 2.2, which I haven't implemented in the Parts Unlimited yet. But if you wanted to have that implemented, you would have to upgrade your application SDK to 2.2, and then you would have those live metric streams, which is a very good way to just get that on the dashboard, and you know exactly how your app is performing in real life, in real time. So for, I would say, team dashboard, team boards that measure or show the performance of the app, it's a good thing to have. But yeah, didn't have the time to upgrade Parts Limited at this time. So that's one of the interesting things that is fairly new that just happened to be available fairly recently. Oh, and there are 2 questions.
We talk about the organization of the DevOps team with the project manager and the engineering part of the team. And then we got into the tool and use of VSDs. I want to go back to the organization part.
Okay.
Microsoft being a company that produce and ship a product, don't have that need of an operations department, most likely, I don't know, but yeah. Some of our customers also have operations department. Mm-hmm. So in the team of the DevOps, you have the pure developers, and the definition could be designers, developers, and architects, and you have the operations resources. Mm-hmm. In your structuring of the team, being the project manager and the engineers, how do some of your customers scale the resources of being pure hardcore operations resources and pure hardcore developers?
Okay. So
views on that?
Yeah, I know what's your question. So Microsoft is operating a lot of services. Yes, we moved from, we used to be a company that was shipping product. Now, Bing is a service that we operate. We're talking of terabytes of data, hundreds of millions of requests. We are talking about a large-scale service operated 24/7. Azure is another service that we operate. Office 365, Xbox, Skype. I have plenty of others, but I just cannot even remember them right now. So we are operating a lot of services, and those teams have their operation part integrated into the same team that is doing the engineering of it. So if you take one of the components of Bing, the ops people, as you define them, are software engineers. They're not operations per se. They are now engineers. They are software engineers. They write code in a language that may not be C#, might be Python, might be something else, might be Azure template, might be PowerShell script, but they're writing code. And the code is, if you think of it, the code is a language, it's a text file that is interpreted by a computer. When you have that as definition of code, then the ops people are actually writing code that is understood by the cloud, or it's understood by the computers it runs on. And the ops people had to evolve on how they were operating to being people writing that piece of code that is integrated into a component that is developed by the other software engineers. So the operation is a core component of the element that is being developed. And the whole team is responsible for the availability of that component. The whole team is responsible for the number of failures and bugs that this component introduced. And that is the measurement of the team. So they are solidar. They have a solidarity of having the whole thing from beginning to end, having code robust and reliable, coming all the way down to the operations. Because I can tell you, when the component is failing, everyone in the team is going to be paged at 3 a.m. And no one likes that. So even the developers are going to make sure that their code is rock solid. So to answer finally the question is, yes, there has been another set of reorganization here, and the operations team is now part of that group of 10 to 18 people that actually operate the whole component. They build, deploy, and ship, and run.
Yeah, so then same experience as me, we see that to do DevOps better, we need to co-locate. We need to, they have to be located at the same place to be able to work together, to understand each other's needs. The operations resources and the dev resources to understand each other and work good together in a DevOps environment. They need to be co-located. But my question was, do you say 20% of an engineering team needs to be operations expertise? Or do you, as you say, solidarically, we all are responsible for the whole solution, so you don't divide it up like that?
I would say everyone is responsible for the whole solution. And I don't divide by a certain percentage needs to be operations. I've seen teams where, and it will depend on the life cycle of the component. I've seen teams where 100% of the team was dedicated on fixing a problem that was appearing in production. They had everyone looking at that piece of code that was blocking production. What happens is more and more you go, the distinction between ops and dev is going to be less and less of very distinctive line. There will be more blur in that distinction because there will be developers that actually write code for operations, and there will be operations people that actually know how to write application code and will write that part of the application code that facilitates the operations. Sometimes, in order to make operation more fluid, you need to write a piece of code in the software itself that understands the infrastructure and does some things on the infrastructure. So who is going to write that piece of code? The operations. And therefore, they will need to know they will need to know the language that the application is developed on. It could be C#, could be Java, could be anything else. Could be Python. I was mentioning Python a minute ago. Could be any language. The language is becoming less relevant nowadays. What is needed is the understanding of a computer language and being able to take an editor and write lines of code. The skills behind that, yes, some people will have more skills in security. Some people will have more skills into data management. Some people will have more skills into other things. But at the end of the day, you need all those skills into one team. And to answer and to confirm what you were saying, yes, it's better if the whole team is located in the same location. Way much easier. There was another question.
Yes, in relation to application insights, although I heartily agree with the previous question as well. But, I was just wondering, what kind of Azure services actually give input to application insights? Is it everything, like document DB? Can you wrap application insights around that and get sort of database statistics, or is it just app services or whatever they're called?
So anything that can integrate the the application insight SDK. So application services is one of them. Document DB, not to my knowledge. I'm looking at Pedro as well, but I'm not to my knowledge. VMs, I mean, applications running into a VM can also rely on the application insights. Functions, Azure Function can integrate on application insights. So there are some services that will not fully integrate, but you can still have some data reported to application insights, mostly rough performance info, but you will not have the deep insights of which page has been loaded, which component has been called, and that kind of thing. That's the depth that application insights gives you through web services or web apps running on VM. Additional data, I mean, the rough data will be what you get from another service that just is connected to application insight.
Do you know if Microsoft has any plans to expand their reach with application insights to include more of the Azure components?
I don't know their roadmap.
Okay.
No, I'm sorry, I don't know the roadmap on this. There is another component which is Azure Monitor that also brings basic monitoring for all kinds of services and resources you have in Azure. So basically, you can consider Azure Monitor as the fundamental monitoring solution that you have on all your Azure resources, and application insight would be the depth that is brought to the application you're building on top of it. And then there are potential overlaps and things that are not perfectly connected, but that's roughly the strategy of those components.
Thank you.
Welcome. Another question? Oh, okay. And then we need to, I don't know, is it a short one?
Yeah, it's
okay.
A pretty short one.
And then we do the break.
Okay. Just wondering, you have now spent a lot of time talking about tooling and tools and how to do this using all the goodies from Microsoft. But when you started the presentation, you said that tools was only just a small part of this thing.
Mm-hmm.
Will you touch more and share some insights how you move from like a Project Phoenix situation into Project Unicorn situation?
Yes, I didn't have much time to talk about it this morning because I wanted to meet the deadlines. But what I suggest is we take about half an hour to talk about that right after the break. And I will talk about the value stream mapping as an exercise and how you go through that.
Cool.
If everyone is okay with that, I will take about half an hour to talk about it. Or a bit more if you feel like.
Super.
Let's do that. And now we have 15 minutes break.
Yes, so let's take a break and be seated again at 2:25.
2:25. Okay. We're going to start in a couple of minutes. I'm getting the deck ready for our presentation on value stream mapping. So as I do that, I'm going to give some generic indication on the value stream mapping. And in the meantime, I'm going to monitor my screen and see when the deck is going to be here. It's a bit long, apparently. It takes some time to get that. So has any one of you heard of value stream mapping? One hand, kind of. Okay. So I don't know if you remember, but this morning I talked briefly of the different practices or different habits from Microsoft that are moving from focusing on the efficiency of a process to focusing more on the efficiency of delivering values for customers. So the value stream mapping exercise, I'm losing the microphone, is a way to identify So the exercise around the value stream mapping is to identify how you deliver value to your customers. How do you go from that code ideation all the way to production in the most efficient way and in the way that delivers most of the values to customers? Here it is. Let me present that. Good. So that's the idea. And it all comes from the history of DevOps. We've already talked about Toyota having the mechanism around lean, and lean manufacturing is about a way of eliminating waste in a process, in a manufacturing space. So what Toyota did in the late 80s, early 90s was let's implement a process in our factories, in our car manufacturing process, in our car manufacturing industries, and see if we have any waste in the chain that builds the car. How do we improve the quality of the cars, and how do we remove those wastes? Well, the idea around value stream mapping is pretty much the same. Is how do you reduce or eliminate the wastes into your processes for software development? And if you think of it, software development is not much different than building a car. Is it? Except it has more bugs. But at the end of the day, the car starts from a piece of paper and produces a car in steel and plastic and electronics. Software, you start from a piece of paper and you produce software that runs and being used for business. The idea of the process that goes from the one end is the same. And if there is one book that I would recommend to learn about it is The Implementation of Lean Software Development. That book explains the fundamentals around lean. And then came in 2010 the idea of CALMS. Initially the L wasn't there. It started with CAMS, which was culture, automation, measurement, and sharing, which is the core of DevOps. And then we inserted lean, that was introduced by John Willis in 2010 to go from this culture, automation, measurement, and sharing approach to having the CALM, which introduced lean in the process. And how do you reduce the waste in your processes? And if you look at it, I have someone in my team from Japan, and I asked him, what was the right kanji? What is the right symbol for the waste? And in Japanese, waste stands for muda. If anyone knows Japanese, they can say if he gave me the wrong kanji or not, and I can talk to him. Tsuyoshi, if you see me. So if you identify, or if you try to think of the different wastes you can find in the process, which are those wastes? We've identified them as a general principle. We qualify them under those 8 ideas. A waste in software delivery can be work is partially done. You start working on something, and then someone interrupts you. You remember, what was the name in the Phoenix project, the guy that is always interrupted to do something else? Brett? I think it was Brett, right. So it actually creates waste, because not only the work is never done, but also switching context takes a lot of CPU from the brain. I don't know you, but when I'm switching context, it usually takes me about 15 minutes to go back into what I was doing. Especially when I'm writing code, it's more like 20 minutes, like where I was, which function I was writing, and so on. Another type of waste is how much extra processes we're doing. Am I doing the same thing again, or is this thing useful? Does it bring any value into what I'm doing? Potentially not. Are we implementing the right features? If in your things, in your application, you're adding features just for the sake of adding features which do not bring value to customers, that's extra work that doesn't make any sense or doesn't bring any added value to what you're doing. Task switching, I just talked about it. Oh, waiting. That's my favorite. I've done that exercise with value stream mapping with many customers around the world. And you wouldn't believe how many of those companies have wait in terms of, oh, we need to wait for the approval of this from that person. Why? We just need to wait for it. Okay? Or we need to get the cab to meet so they can approve the change. Did they ever deny it? No. Why do you have a cab then? If they never deny anything, what are they used for? Approving things? Better go to the administration and get things stamped. That's about the same process. Oh, I've been waiting for the email. Okay. And if you don't get the email, what happens? I wait. And then I wait. Okay. Motion and defect. Defect is an interesting one. It's a big waste because if you, let's say you introduce a defect in the process or in the system, I was talking about the technical debt, you start to introduce bugs that will happen later or that will not be surfaced, or you will have code that you don't even know what they're for because they're so complex or not documented. So you have defect that is in the code or in your app, and you don't know what they're used for. So you keep carrying some debt that will make it heavier and more difficult to manage. And then the management activities. I was talking about waiting the email, waiting approvals. That kind of things get into that, but it's also the manager that says, hey, you know what, I want to talk with you and you cannot submit code before I have reviewed that. That doesn't really help a lot. So in the software development practices tool, how to identify those wastes, there are different mechanisms, different methodologies. The first one, which is the one I'm going to talk about now, is the value stream mapping. But there's also the theory of constraint, the pull systems, the queuing theory, motivation, measurements, and test-driven development. I'm sure you've kind of already seen those at one point somehow in your life. The other one that is very, very often used is a theory of constraint, which means you create limitation factors between the teams so that by itself the system cannot overburn a certain team or cannot go into something that is unmanageable. I think Amazon has implemented that theory of constraint in their retail environment. So each team can pretty much do anything they want, but they are constrained by other elements that are out of their control. So each team is constrained by the system itself. They cannot have more than a certain amount of attention by finance, for example, and things like that, which created certain autonomy, a certain way of constraining those teams by themselves. So the practice that I wanted to talk is value stream mapping. And the value stream mapping is basically giving a very high-level overview of the process of software development from beginning to end without going into the gory details of every single step that is being done. I'm going to give you a couple of examples. We don't care if it takes 5 minutes or 10 minutes to boot a machine to do software development. What we care is more, how long did it take to do the release of that specific version of the software? That high-level overview, from my experience, is usually the first time that a team sees this process from beginning to end. And believe me, most of the time, your executives, your boss, or boss, have never seen that process ever. It really helped that visualization. It makes the things concrete. It makes the process touchable, tangible. And it allows people to touch where the waste is. They're capable of touching it by the finger. And it makes a big difference. It's a big thing to see it on the board where it's written versus people talking about, oh yeah, we're spending 5 minutes on this, or we're wasting 5 hours on that. One is totally abstract, the other is real. It's visible. They can touch it, see it. It also brings that common language across the organization that everyone can use and talk about the same thing at every level, from the executive to the developer. And you know what? By having everything mapped on the same board, makes it easy to identify what needs to be addressed first. It helps to identify those improvements that need to be made in a short term, medium term, and long term to get things done. Another thing that I've realized, and it's extremely interesting when you do that exercise in your company or in any company, most of the time, those teams in larger company have never seen all of them together in the same room. They touch the same product. They touch the same code. But that whole team that goes from ideation to code to production has never been in the same room to talk about the product. It's usually the first time that they all get together and get that rich picture of the process. There are a couple of books that I highly recommend if you want to exercise or do that exercise yourself. One of them is The Lean Enterprise. It's a book about that thick. It's rather easy to read, and to be honest, the first half is really what is interesting for what we want to do. The other one is Value Stream Mapping itself, gives tools and tips and tricks on how to get deeper into the value stream mapping exercise. Those two books are really interesting to read. if you can order them online. You will find them. But I wanted to walk through the exercise itself with you. We have a team at Microsoft that is publishing our videos online. It's called Channel 9. Potentially you've heard of them. You watch some videos. So Channel 9 is a team that also does software. They build their website, and they publish the videos that we produce on their website. So they have development mechanism. And we have done the value stream mapping with them. Why not? Right? I mean, it's a software development team, small team, but they have a process. So we've done the VSM with them. And that's how the VSM looks like for their web app. Or I should say that was how the VSM looked like with their web app that was done in August. Some of the things are still relevant, some of them are not. You see different blocks that are grouped in blue. Sorry, you have different blocks in black, and then those blocks are grouped into blue box. This is the way of grouping each independent step of the process. Each of those blocks, so the one on the very left, is the production step. It's production release, that's what we wrote here. The center one is the load testing, the workflow. So whenever they do a new release, they have that load test approach. And here, the very one on the very left is the code and test. Test, load, and production. That's how we've grouped those things from a very high level point of view. How we've done the VSM, how we got there, and that's potentially the interesting piece, is how do you go from a whiteboard to that drawing? So first of all, you start with the architecture overview. You want to do that before you really enter the VSM itself. And believe me or not, most of the team don't have this overall architecture understanding. Most of the teams I've been engaged with have an understanding on the component that they control or that they understand, but they don't have the overall architecture. So you want to have the whole team in the room to be able to get the architecture, not just the production architecture, not just the dev environment architecture, but the architecture itself that is being used by the app. That brings this overview of the application, and you start to get an idea of what are the pain points. Interestingly enough, it's always good to have that exercise done by a third party, someone that is not from the teams or not from the company, because you get that very external point of view, neutral point of view, the Swiss. I'm there just to match what I hear and write it on the board. You're not taking part in the discussion, because I can tell you there will be some points, some disagreements. The architecture point should take no more than an hour. You don't want to go into a lot of elements here. You don't want to spend a whole day doing the architecture of the app. You want to get at a higher level, get the big buckets, and that's it. And you want to focus on the production environment. That's what is important for the value stream mapping. So 1 hour, big buckets, production. And then you go backward. You start from the production, what has been produced on the last release. So you take today's deployment in production and you roll back to the code that has been created for that specific release. And you go from left to right on the board. The ideal approach is to get those very wide sticky board nodes, like that kind of like a whiteboard thing, but a sticky note, so you can put them, align them on the whiteboard. So you start from the left, and you roll back. Each step will look like this, more or less. So A, you start with a customer on the very, very top. Then at the intermediary level, you will write the technology that is used, the tools, the services, those kind of things that are used. And on the bottom piece, the third layer, is the process itself. So the process is decomposed into each single step. You give for each step a title, and the title can be anything. It can be, in that case, pause deploy steps, scale configuration change. It can be deploy to production. It can be wait for something. It can be anything. But those are the different steps that are implemented. For each of those steps, you define the number of people, actually not necessarily the person itself, but the number of roles or number of equivalent full-time person that are required for this execution. So in our case here, that's a step that required 2 people. So you know that to execute that part of the equation, you will need 2 people to work. And you define, you write down what are the roles of those people. Are there program managers? Are they developers? Are they security people? Are they executives? Are they operations people? Are they from the infrastructure team? Are they from the networking team? So you want to know what they're doing, what are their roles. And then for each of those boxes, you're going to write down 2 numbers, and you're going to calculate one of them. What you want to measure is the process time, the PT. The process time is how long did it take to execute that specific step. Maybe the deployment in dev took 2 hours. How long did it take to wait for that step? Did I have to wait 3 days to get there? Well, my wait time is going to be 3 days. And you calculate the lead time. The lead time, or LT, is the sum of the wait and the execution time. So if you waited 3 days and that execution lasted 12 hours, then the lead time is 3 days and 12 hours. You do the math if you want to calculate in hours. Then you go to the step that happened before that one. And you identify how the work has been handed over from step -1 to step N. Was it a handoff process, or was it just natural things done by the same person? If that's a handoff, meaning you step to a different team, then you do a dotted line. If it's the same person, then you do a full line. So far, so good. Once you've started doing this drawing from beginning to end, you group the boundaries for each major step that happens. So that's when you do the process grouping boundaries. You usually do it with a different color. So if you wrote the process itself in black, you would do the process group boundaries in blue. And here we do the load test workflow, which run every 6 weeks, and you group all the steps that are done on that very specific process boundary. It will help identify the different environment, and it will help identify what are the group of steps that needs to be reproduced at which frequency. Then you have your process map complete from the beginning to end. What is missing here, and yeah, here it is. Sorry, I missed that one. Once you've done your process group boundaries, you want to identify the wastes. So for each step, or each handover, you identify what are the defects that happened. You want to mark them in red because that's how they jump to the eyes of the people. And you want to be constrained to a certain list of defects. And you don't have to find the defect on every step. There may be steps that do not have a defect. But if you find the defect, you want to stick to that list. Could be a standard defect, which is just incorrect information, things are missing, you have a disruption that needs to be resolved, like a broken build. That's one defect. It happens. Doesn't mean it's a lot of things. Or it could be an incorrect configuration, and that can be an easy fix. Then you may have a manual operation that is being done, a manual handoff. You may need to have a meeting. That's a manual operation. You may have a wait, waiting for a change advisory board, waiting for a meeting, waiting for someone to complete something, waiting for resources. Oh, I needed to fill that form to get a virtual machine, and it took a week to get that virtual machine. You may have things that are just partially done. The code I got, the artifacts were not tested. Some of the tests didn't run. We didn't get that correctly done. We had an incomplete setup. The virtual machine that we expected were not configured with all the tools, so we spent half a day to add those things. I've been doing task switching, and yeah, I've been interrupted because we had an outage somewhere else, and I couldn't complete that step because I spent the whole week to do task switching. I had to work on something else. Extra processes. We need to do that meeting every week. Why? We don't know. We still need the meeting. Just a meeting. We just validate everything. Is it useful? Maybe not. Extra features, which we talked about, things we may need one day. You implement it ahead of time. Like, you're thinking that maybe in a month or in a year you may need something that is in those lines. So you implement the feature now because you feel you have time. That's extra feature. And the famous heroic. The heroic. Everyone has one of those in their company. The person that is indispensable to fix things. The tribal knowledge that has been built over years and decades of companies learning. that post-it that is on the board of the team and knows how to fix this problem that has been there forever, and no one had the time to fix this problem. But you know you have to type this command when the problem happened, and it's written on the whiteboard, on the sticky note. Or the person that just becomes the one that will do the coordination across so many teams because he knows everyone in the company. Identify those defects. And then you identify what we call the scrap rate. If you want to be more positive, you will look it in the other way around, like what is the usage. I prefer to look for the scrap rate. It kind of kicks the ass of our executives. It's a good thing to do, usually, if it's well done. And the higher it is, the higher ratio of defect exists into the process. With Channel 9, in some cases, we had 20% scrap rate, which means 20% of the time is wasted in things that are not related to writing or improving the solution that is being built for Channel 9. So that being done, you map the process, connect the dots, make the arrows, identify the defect, do the process group. Then becomes the nice exercise. You identify and write recommendations. I highly recommend to use a green pen for that one. We are all connected with red bad, green good, green go, red stop, that kind of things. It's part of our DNA. So you write those recommendations. Those recommendations will be connected to the defect that you have identified before. Those defects will help you to identify the low-hanging fruits in your process. And as you look through it, if you think of it, it's a step into fixing Phoenix project. It's a way of saying, okay, we start doing DevOps by just looking at our current process and moving forward. Making those little steps, those little baby steps, is really how you can go and have DevOps practices in your company. The Big Bang thing will not happen. It remains a theory. It will not happen in your company. You will have to do baby steps. And that's how you start those baby steps. You start with those little things, hack those processes one by one. Potentially what you can do, you organize a hack fest in your organization, in your team. Get the problem. You have identified the problem through that one. Say, okay, now this Friday, or Thursday and Friday, we're going to take everyone off work. Actually, no, they're going to work. They're not going to do their daily work. And they're going to hack one of the problems. And you start forming the teams that are going to do DevOps, if you think of it. You start having people going together and working on the same problem, fixing those problems one by one. And because it's time constraint, well, you'll see how you go in a 2-day time frame, or 3 days, depending on how much you want to invest. I usually recommend to do like 2-3 days because it's not too heavy on the work, on the daily work, but at the same time, you have enough to do things and you can show result. Because if you're investing 3 days of a teamwork to fix something that is wasting weeks of energy and value, You're already making progress. You're all making huge progress. And that's easy to show. You've reduced the lead time from 6 months to maybe only 2. And that's something that is easy to sell to any management team. Couple of things to keep in mind. Your audience is important. The team that is going to be here is important. You want to make sure you get everyone in the room. Anyone involved in the process from beginning to end has to be here. Developers, architects, software engineers, UI, architectures, product owners, DBA, system teams, everyone should be here. I recommend those, as I said, the sticky notes, like white, big sticky note that you can move around. The right thing why you want those things to be on paper and not on a whiteboard, because after that, you bring those papers in your team room, put it on the wall, and everyone has the value stream mapping in front of their eyes. They can look at it. Everyone can look at it. You can even put it into the hallway. So everyone that walks around sees that process and see the work that has been done. And in a few months from now, you do the exercise again, and you can measure the progress. And you can measure the progress that has been made. By doing that, you show that in 6 months, you've made progress over something that was broken for many, many years or many time, and you've already started to make those progress. That's how you show that you've been doing DevOps. Maybe you haven't reorganized the team yet, yes. But you've started to make that progress. And that's really how you want to do. Oops. I like this picture. That shows you how long can be a value stream mapping for one of the companies we've been working with. You want to articulate the result to your executives, and then you organize a hack. You decide what to hack. As we say with my Japanese team, we say it's a Kaizen event because it's kind of the moment where everyone will focus on the same thing and start hacking that specific things with those 2 or 3 items that you have identified through the first value stream mapping process. It's a very nice exercise, and it's a very good way to enter DevOps with too many disruptions, without too many disruptions. Any questions? Oh, there is one question.
2 quick ones. How do you calculate that scrap ratio thing? I didn't quite catch how that
The scrap rate is a ratio on the amount of time it takes, the lead time and the process time. Okay. It's pretty much the percentage of. So if you have a lead time of, let's say, 5 hours and a process time of 1 hour, the scrap rate would be?
What was the question?
Oh, you have a lead time of 5 hours. Yeah. You have a process time of 1 hour. The scrap rate is?
1 to 5?
80%.
And if you have a development team that spans several geographical locations, how would you organize these events?
If you have a team that is across geographical region, how do you do that? Ideally, you buy many tickets to come here, or you all go somewhere and do it in the same location. That's the ideal configuration. I know it's expensive and does not necessarily is easy to sell. Some teams have tried to do it over Skype with video. Works a bit less, but it's doable. However, if you do it remote, I strongly advise to keep the video on during the entire exercise. The value stream mapping usually takes about a day. I've never seen that happening in less than 5 hours. So 5 hours being remote, it can be tough, especially with time difference, can be challenging. All right, any questions online? All right. Cool, so that is the value stream mapping. If you search on the internet, there is a bunch of articles and documentation around that. So you should be able to find additional content, but I was going to say that Pedro also knows how to deliver or how to do the value stream mapping. This is something we've done a few times, and yeah, we have some experience around that. So Pedro would be the right point of contact here in Norway. All right. Good. Telemetry, we've done it. Let's talk about hypothesis-driven development. We've touched a bit on the telemetry, which is in center. I want to switch a bit gears and talk about two other practices around DevOps. The other ones are testing in production, or I would say A/B testing. We've touched a bit the testing in production earlier today around routing X% of your traffic to a certain version of the website, routing the other % to a different version of your website. Now, I want to do a bit more, and you want to have production A and production B with a deep analysis of what's going on, even with routing the users based on certain criteria to an A version of your website or to a B version of your website. So that's what we call the experimentation with A/B testing. And the other topic I wanted to talk with you about is the fault injection. So the fault injection is, as I shared about this morning, the mechanism that Netflix is doing with Chaos Monkey is how do you ensure that your website is resilient regardless of what happens. We just know that in the cloud, things will fail at one point. That's the only thing that is granted. And you want to ensure that the issues that are identified or the issues that will happen will not interfere with the production environment. Regardless if it's a website, if the database that is breaking, you want to ensure that all those things are not only monitored, but they are self-healing. So you want to be able to test on that problem on a regular basis. All right, so trying to keep the microphone in place. So I'm going to go back to my website. parts unlimited. And to do A/B testing, I'm going to use a third-party solution. So to be very honest here, on the A/B testing, we rely for most of the time to third-party solutions that actually have that implementation. Excuse me 1 second. All right. So the solution that we're using for A/B testing, it's a partner that is working with Azure, but working with many other solutions. It's called Optimizely. So Optimizely is offering the ability to do experiments, and it's doing those experiments based on the criteria that you define. So in this case, I have my Parts Unlimited website, and I'm going to run an experiment of different versions, the version 1 and version 2. Okay. Let's switch browsers. Okay, here we go. So I've created two variations of my website. So I have the original website, which goes on Parts Unlimited core Azure websites.net. And you can see here an extract of my website. Actually, it's the real life. I mean, you can go through it. However, you can, and that's what I'm going to do. I'm going to create a variation based on that. So the first variation I've created a change in the background color to a different version of my, so by default we have black. I'm going to change it to a kind of a blue. So website is behaving. Here it is. So you change the background color. I put that one into the RGBA version. And then what you want to do in that experiment, you want to track the number of clicks on the shop button. So how do you find the shop button? So I'm going to track the click on this element. And the shop button, name of the shop button is based on the name of the button into the web page. Oops. And you say, okay, this is going to be converted when people click on that button. Then you can create as many other variations as you want, including variation number 2. That one is a bit more tricky, because what I wanted to do is I want to remove on the first page the image. So there is an image that says fork me on GitHub. I want to remove that one. And so that's the image that is being removed. And you say, well, I don't want that image to be on the web page. After that, you can define how much traffic you want on each variation. So in our case, we put 33%. And you run your experiment. So now my experiment is running. And once you have the experiment running, the question that is usually asked is, how do I know that this website or this third-party solution is going to track the right click or the right info? Well, this is done into the code of the application itself. So if I go to my A/B testing version, in the source code of my website, it's into the layout. There we are. I'm simply adding this kind of line, so it connects to the CDN of the Optimizely with a GUID, and that makes a connection to JavaScript, and it will make the connection to Optimizely itself. So the amount of code that is required to implement that A/B testing feature is very limited. It does not interfere too much on the website. Now I need to push that one in production. And I'm actually using the same build mechanism that I showed you before today. You see, it's exactly the same build process. I haven't changed it. And it will take a minute or two to get there. So let's go to Optimizely and browse the website. Oops. So that's how you configure the page, by the way. You define the URL that you want to use. Make a simple match. You could actually make a scenario. You could be a bit more fancy on that. It doesn't have to be a specific page. It can be a multiple set of pages. So you see the dev environment has the fork me on GitHub on the top left. So once the A/B testing version is being deployed, okay. So when that version has been deployed, I will have some iteration that will not have the fork on GitHub and some iteration that will have the fork on GitHub. We need to wait a bit. It's already morning in the East Coast, and there's a lot of people doing build as they start their day, so we may have to wait a bit for a build agent. The build agent, by the way, is free on VSTS, so when you create your VSTS account, you have one build agent for free hosted on Microsoft, so that's something you can start building immediately. The only constraint is you may have to wait a bit to get a build agent in the afternoon here in Europe. On the Optimizely one, I wanted to show you how you make the campaigns. it's in your audience. So I remember someone came to me earlier today and said, hey, how do I filter who can access which version and which A and which B? So you can define by tablet, desktop, or you can create a new audience. And you can define by browser, by device, by IP address, by location. So you can say, hey, I want anyone who is into those locations. So it could be Europe, could be US, could be anything like that. It could be also a referral URL. So in the case you want to have a private A/B testing, you can create a referral URL, and that would be the entry point that is used for that. You can create your own uploaded list of features that's not in the trial version of Optimizely. It's something you would have to get deeper into to get those features. You can also create custom attributes and use those custom attributes for the variations test. So you go to a website, you have a custom attribute that is passed from the initial version of the website. It could be a referral, by the way, and then you activate A or B, and that's how you get that filter. In my case, I just created an audience based on the device itself. So if my visitor is desktop or laptop, or if my device is on a tablet, or it is an iPad, then it's part of my audience. So basically, I grab everything that is existing on the world, but cell phones and devices like that. And we still don't have an agent, so we have to wait for this one. I can show you the result from yesterday. So if you go to the experiment, go to results. So that's the result I had from the previous test I've done. It was a few days ago. So you have the first variation that had one visitor. And then you remember that my conversion is based on clicking on the shop button. So the fact that I click on the shop button had a conversion rate of 100% because every time I went to that page, I clicked shop. So I can guess that if I do that variation, then I'm improving my sales by X%. That's pretty much how they go into this approach. Now you can have the number of pages, the number of visitors, and they're also making improvements. So if you run the same campaign, A/B testing over a certain period of time, and then you run it again, let's say you run it on a weekend, and then you run that same campaign on Thursday and Friday, you will be able to compare the improvement from the first campaign to the second campaign and see which is the right time to execute that new version of your implementation. Of course, the amount of data is limited in a demo kind of environment, but if you go into something more advanced with more data set, you will be able to have, of course, a better granularity, better result, and that's how you get into something that is useful for business. Connecting DevOps to that discussion, well, the idea of DevOps is to enable the business to do things that they believe is right to improve the company's capabilities on the market. And that's a good way to do it. I'm talking on a simple e-commerce website, but you can do it on any aspect of your website or your APIs or your environment if that's something you want to implement. Again, it really depends on the business and your environment. But that's really something that kind of happens. And we feel that Optimizely is a good solution that integrates very well with Azure. But there are other solutions. You just pick that one because it's a sample that we've been working on for a long time. Any questions on A/B testing? Variations, monitoring? Okay, that's pretty clear then. I guess. Let's see how our agent is performing. I don't think it has started yet. Nope. Let's consider that one then. You don't need to take a queue in the busy line. So, I want to walk briefly through feature flag. Someone asked a question earlier during the break around feature flag. Unfortunately, that demo does not work. I have an issue that I haven't been able to fix before yesterday. But I will show you a couple of things here around feature flag. So, the main point around feature flag is how do you, let me open Visual Studio first. As I said, I'm incapable of doing two things at the same time, especially speaking and thinking at the same time. So, as Visual Studio launches, feature flag is something that a lot of people talk about. But as someone told me, it's I haven't seen anyone doing it, or I haven't seen a lot of people doing it. The reason being is, feature flag is not something you can activate in a product. You will have to do it in your code. The feature flag activation is something that you implement in your code, and you implement the feature in the code, as well as the flags itself. So, if you think of it, you're going to deploy your version of your app with no feature flag today. Then you're going to implement or to deploy that version n+1 of your application that has the new feature implemented and the potential activation as a configuration file. The feature will not be used. It will just be there, but not activated into that new version. And then the next iteration will be simply updating the configuration so that you say, okay, now I can use it. So you're not redeploying any code per se, you're just redeploying a configuration file that will activate that feature. And then you can think of further deployment that will decommission the previous version of the previous implementation of the feature flag. So in the Parts Unlimited website, wow, that's good to hear. So, yeah, I guess everyone heard. Maybe not online. Oh, yeah, they view the comments or things online? Okay, so I don't need to repeat. But that's actually good. So, yeah, it's it's something that is used a lot in the retail and space. It's good to know that it's being deployed because it's really an advanced practice around DevOps. And we've seen that a lot in the retail. Actually, in the US, I've seen it a lot. I've seen it a lot on all the e-commerce website, all the internet web-based scenarios, because it's a very smooth way of activating features and decoupling features, I would say. So if you start off thinking in a microservice approach or in microservicing your application, you should start thinking in that direction. You want to have feature flags because those microservices will have an independent lifecycle. They will live on different technologies, on different frameworks. Your microservices, some microservices may run on .NET, some microservices may run on Java, and some microservices may run on Python. Well, the implementation of feature flag will allow to have each of those microservices having their own lifecycle, their own deployment mechanism that will be different. And you say, okay, well, I'm implementing the feature, but how to activate? Here's your code. You just use that feature flag, and you're good. That's pretty much how it works. So you're very decoupling those microservices, and that makes the whole application way much more fluid and way much more flexible in terms of evolution and deployment.
Sorry.
You turn it off.
Here we go. Yes, so the comment from online is that they do not use redeployment to enable or disable feature flags, but they do it from a portal.
Okay.
So,
yeah. That's another good mechanism.
Yeah.
Yeah. Where was I? Oh yeah, I wanted to show you one of the implementation on the parts unlimited of the feature flag. So it's a class that we've implemented on this one. So pretty much we wanted to add a feature flag on the phone number registration for the users on that website. So they register, they enter the phone number, and we wanted to add a feature that was matching the numbers and making a red box around the box when they were entering the wrong number. So we created a class called feature, and we added a feature manager that was actually getting the status by key and verifying that the feature was enabled before it was actually implemented in the code. And then in the feature manager, you do that verification when you run the code to verify that it is actually implemented or not. And that's how you implement the feature flag. So you verify if the feature is on or not off before it actually runs or not into the code. That's pretty much how it works. Unfortunately, again, as I said, we had some issue here, and I haven't been able to get through that full demo before today. So I don't have a full demo running, but yeah, that's pretty much where we are. I wanted to show you that piece of code before moving to the next iteration here. Any questions? Yeah.
Hello?
Yeah.
There's already there is a service called Launch Darkly.
Launch Darkly, yes.
Which lets you define feature flags, and you can also, do traffic distributions. You can check out new features before you launch 100%.
Mm-hmm.
Do you know if there's any on the Azure roadmap for creating a similar service?
I'm not aware of a similar service that we would integrate with Azure. However, we work with Launch Darkly.
Okay.
and we have a good connection with our with LaunchDarkly. So if this is something you want to implement with a third party, LaunchDarkly would be the one to go for.
Thank you.
Comments online?
Hang on.
We have a big room here.
Yes. So from Thomas online, he is saying that there is an open source feature controlling service called FeatureB, which is open sourced.
Okay, I didn't know. Good. OpenB?
FeatureB.
Oh, FeatureB.
Yes.
Let me see. Like this.
With 2 E's.
Like a bee.
Like a bee.
This one from AutoScout.
Yep.
Interesting. Okay. Extremely good to know. I will look at it in the flight tonight. I'm going to clone that code before leaving. Thanks for the info. Who said? Thomas. Thanks for the info, Thomas. Is it? Cool. All right. So the last piece I wanted to talk about today is fault injection. So we're not going to do Chaos Monkey. Although we could do some form of Chaos Monkey, that's not what we have. I'm going to talk about more the fault injection on Azure websites. So I'm reopening my application, our Parcel Limited website. And what I have done here, I have deployed this application in 2 different regions in Azure. So I've been basically taking this application. You can publish it directly. Sorry. Excuse me, I'm starting already at the very beginning. So, so in our solution, we have those 2 files. And those 2 files are the one I've been using into my build process this morning. When I've done the build and deploy, I've been using those 2 files to deploy through an ARM template my full application, including the website, including the database, including application insights. So what I'm using right now, I'm going to do exactly the same thing. I'm going to deploy it. Right. So I'm going to deploy to my subscription. And I'm going to create a new resource group. So it's going to be leap main. And we're going to deploy to North Europe. So for the template, full environment setup merge. Full environment setup merge parameters. Okay. So I'm entering the parameters here. Leap main server. Typing the password. And I'm deploying a website as well, so I'm using the hosting plan name. Leap main plan. Okay. So what it's doing right now, it's actually deploying the whole resource group in Azure. Yes. So it will do the whole thing, and it's going to take a bit of time to do that. So I'm not going to wait until it does the whole deployment. It takes about 10 minutes to do the full deployment. However, consider that I've done this in Northern Europe, and I'm doing the same thing in Eastern Europe. In Southern Europe. West Europe. I was like, no, it's not East, it's not, so West. So I'm going to deploy the same environment in North Europe and West Europe. And we can consider one of them as being the main environment and the other one being the backup environment or the standby environment. That's what I've already done. I've already done that into West US and East US. That's why I got confused with East. And you can see I have my two environments, the high available and high available standby. So on the highly available one, what I've done, I've configured my, my application service to have a replica into the standby environment. Sorry, on my database. So my main database, here it is, parts unlimited database. So for the database, on the main that I have into my main environment, I'm doing a geo-replication. So what Azure is going to do here is going to do a copy of the database across the region, replicate the data as they enter the main database, and in case of failover, is going to allow me to do a read on the secondary database. So I have done come on. It is. What? Stop. So I have currently East and West, but let's say I want to create a replica in South US, Southeast. Central US, there we go. So you define how the secondary will look like. So you want to make it readable, so you can read data from there. You will have to have a server over there to host the database. Of course, that makes sense. In my case, I already had the resource group deployed into East US, but in the case you want to have a copy in Central, you define the type of server you want based on the performance that are required for the database. Basic is good for me in that case. And go. So Azure is going to do that replica for this database automatically across the region. From an operation point of view, you want to keep those things rather close rather than going across oceans because of latency and potential network bandwidth problems. But it's better to, so like East US, West US, North Europe, West Europe. In Asia, you would be able to use that in the same Asian areas. So you even have a map that helps you understand where you are and what is the replica that you're having and the seeding that is happening. I don't know if you see the little row, the dotted row, that shows the seeding happening on the database in Central US. All right. So we've created those databases, those scalable environment. So that's how you start creating replicas. Now, on my website, on the main application service, what I'm going to do I'm going to define my website and define how much capacity I need for that website. So in that case, I have already 2 instances. I'm going to increase to 4. So I'm going to have 4 instances of my main environment in production. And here we go. So the next thing I need to do is to ensure that my standby environment points to the right database. The application settings. So my standby environment points to the database. So I'm going to change the connection string. So basically, here I'm pointing to my standby server. That's my data source. So you just edit the string and modify it to the backup server. And the last piece we need to do, that I've already done, is go to the traffic manager. So we are going to create, in front of the page, the traffic manager. And the traffic manager will actually reroute to primary or standby just in case the first one fails or the second one is available. So you basically add the different endpoints to your traffic manager with different priority. So it goes to the main server first, and it will go to the standby server in second. So in case the main fails, it will go to the standby server. And of course, if my first server fails, we highly believe that the database will be unavailable as well. So that's why we've changed the connection string to go from the primary database to the secondary database, so it can actually still read data from the secondary database. You can add additional endpoints if you want. So we could do test. It could be an app service. And then you can look into all the app services that are available in your environment, and it will pick one of them. So we could replicate a third environment and go to that environment. For example, I could go to this one that I've created in West Europe, and it will fail to West Europe in case the US is totally down. So in case the network fails, you could use that one. And priority number 3. Traffic Manager doesn't have any understanding of what the app is doing. It's basically doing a route based on the protocol, and will route if the protocol does not respond. So, so you have to keep that in mind. This is not an intelligent solution that will understand what goes into the application itself. It will just go and reroute based on how the website is responding. You want to reduce your DNS life for the case of demos if you want to play with it. In production, you would not go for 60 seconds. That's kind of too short. You want to have a regular DNS time. And the monitoring of the endpoint, as I was saying, is really basic. It's an endpoint monitoring on port 80. If port 80 responds, that seems to be good. If port 80 doesn't respond, then that seems to be bad. So it's a very basic monitoring here based on the path. Let me remove that test. Because that endpoint was not valid, was not responding. So we are good. We have A and B. Now let's connect to that website. And I'm going to put that here. I'm going to my different websites. So we had the main running, right? So let's go and stop main. So yes, I want to stop main. Yes. So main is stopped. So reroutes, it's taking some time. You remember the 60-second time management, so it's going to take a bit of time to balance. So it will detect that and switch. Maybe I should refresh. Yep, it stopped. Yep, it's the one. well, it will take, as I said, about a minute to switch. So that's how and we're talking about failover. We're not talking about resiliency or that kind of thing that is done by a different mechanism. We're talking about a resiliency across the regions. So that means usually a big, big problem. It shouldn't, because I stopped the app, so it shouldn't respond. The backup, though, just verifying that the backup is, the standby is running. Yeah, the standby is running. I've seen weird behavior with Chrome as I was doing those tests. Chrome seems to have its own caching mechanism for DNS, and React, yeah. Yeah, exactly. So Chrome reacts differently on the DNS caching mechanism. You see? I did, yeah, Control F5 as well. So I haven't dig into the details, but Chrome seems to have its own caching mechanism on the DNS names that actually behaves differently than what you could do with Route 53 or Traffic Manager in Azure. So that's usually the interesting behavior. So yeah, you see the trafficmanager.net, which means you would have to do a CNAME in front of it to get to your own name, but that one is actually routing correctly. Yeah, I will have to dig a bit more on the Chrome behavior. That's something I've discovered recently. So we have the backup. If I do the switch back, if I stop my standby, so I've stopped the standby. Now I get the same error. So both sites are stopped at this time. If I go to my primary one, start the primary again, refresh Traffic Manager, let me copy, let me restart a new instance. Not yet. Oh, it's going to take the 60-second thing. So we're going to hit the 1 minute limit, and it's going to switch back. I also wanted to show here the performance testing, the performance testing approach here. So verifying that we have a website before I go anywhere. Taking more time than expected. Yeah, I will do that. Nope. I can try Chrome. Well, Chrome should be. Should be okay, yeah, it looks like. And try this one now. Oh, well. Okay, interesting. Okay. So I wanted to go a bit on the load testing approach. Now that we are on the main one. Do you remember that the main one have 4 instances? I've been running 4 instances on the main one. So what I'm going to do, I'm going to generate some load testing on that website and see how it responds over time. So I'm going to run a performance test. And I'm going to run the performance test against that one. So what I want to test here is a simple test on the video URL I've defined on Traffic Manager. You could also import Visual Studio Test. So you can do a manual test which is loading the page, or you can have a set of tests that you've created with Visual Studio, and then you import that Visual Studio Test suite into your environment. And I'm going to run the test from, let's say, Northern Europe. I'm going to simulate the load of 250 users, and we can run it for 20 minutes. So that is going to run the test. So that's pretty long. It's going to acquire resources during like 15 minutes. So it's going to create those 250 simultaneous users, and we'll run the test, which is loading the page, hitting the page on those 250 users simultaneously for 20 minutes. One of the interesting things to do is to start reducing the number of cores that you have on the website at that moment, and see how the website performs when you reduce by 1 core, by 2 cores, and see if the capacity you've made, or the estimation of the capacity that you have made is correct for that website. Ideally, you could do, or you could do that test on the production environment, or you can do it on a test environment. Remember, you have different slots. You can actually point to the different slots to do those tests. I'm going to let that one be queued, and I will show you the result of the one I've been running the other day. So that one has been running for some amount of time. It shows how many requests have been successful and how many requests failed. The request that failed can fail for many reasons. And here it reports the type of errors that we have on the HTTP level. Is it a 400? Is it a 500? So in the case of that test, I had mostly the 403 and some 500, which was an internal server error. You even have the numbers. So you can order by number of count, and you would see that this one is actually the most common one. So basically, it was showing that the server was totally unable to handle the request coming. The 500 error message was definitely a message that the server was not following up. The 52 is the bad gateway, is more a traffic manager issue, which is an interesting one. It's something that we've been reporting. They're working and looking at it. Now you can look at the overall performance of a load. Number of requests per second, the average response time, and the CPU time and memory time. On the performance test, when it runs, you can also go here in more details. So you have that CPU info, the memory info, the details, number of megabytes being used, the minimum, the maximum, and the total amount of RAM that has been used and the CPU time that has been consumed. And then you can go again into the details of the different requests. Now, you can also get those data when it runs. You have more data here on the application plan, but we will need to wait 15 minutes to get those. I wanted to get those data here. Yes, that's actually what I wanted to show you. but I cannot see it here. It apparently appears only when you have it running live for some reason. But yeah, technically you could correlate with application insights. That's the idea. Okay. I see Pedro making me a sign. Yes, we're actually close to the end. But yeah, I wanted to show you the performance under load. That's the performance over the past hour. But when you run it over time, when you run it like in real life, you have that performance load and connect with application insights. So we'll have to wait a bit until that comes. We'll have the resources in 10 minutes. And you will have the performance under load over here, which will show you actually exactly what's being consumed, and you get the granularity around application insight. Yeah, okay. So that pretty much goes through the end of what I wanted to talk about today. And I will leave that so you can see when it starts running. So what we've seen through the day, I want to walk through the discussion we had around DevOps. I will show you, however, let me bring some slides back so we have. So we walked through DevOps, what DevOps stands for. We walked through how the planning works, the Kanban, the work items, the bugs, the iterations. We've worked around how you go through continuous integration, continuous deployment. We touched how telemetry works, how application insight can be used for that telemetry purposes. We've seen how you can do testing in production with injecting a temporary website into your environment, seeing that slot being used and how people can behave. We've seen what the experimentation and A/B testing with Optimizely can look like and how you can run those campaigns, how the result of the campaign can be used by the business, because at the end of the day, you're not doing DevOps for DevOps, you're doing DevOps for the business. And finally, we've been evaluating and seeing how fault injection works, how you can do load testing and fault injection in production, ensuring that you have the resiliency of the website. What is not on the agenda, and we've covered a bit more in the day, is also how you can start doing DevOps and how you can identify those low-hanging fruits with the value stream mapping exercise, which helps you to identify the easy-to-hack exercise that you can do with your team to start implementing those processes. And it can fit into any of those areas. What you have to keep in mind is you can do DevOps by starting on any of those points. It doesn't have to be continuous integration first or infrastructure as code. You can start by doing fault injection because that's what matters for your business or what is more relevant for you. You can start by doing the A/B testing because that's really what matters and that's what is going to be used immediately. The only thing that I can say is that DevOps, all up, is a journey. It's about continuous improvement. It's about continuous learning. And you will always learn new things as you walk through that implementation. And everyone has a different implementation of DevOps, which makes it extremely interesting and interesting to share as you go through the different events and the community around DevOps practitioners. So with that, I'm going to switch back to our latest fault injection, and I will wish you a very good evening. We have 15-ish minutes more until I have to go, but if you want to leave now, you are very, very welcome to do so. Thank you. Sorry?
Will you be sharing the slides?
Yes.
Good.
Slides will be shared. And that's our loading performance.
We almost forgot, sorry.
Oh.
We wanted to thank you for coming all the way to Norway. So as a small token of the appreciation, we brought some good Norwegian milk chocolate for you.
Thank
And
you.
Of course, you cannot have been in Norway without our iconic Norwegian symbol, the Norwegian troll. So thank you
that
very
needs
much.
to go on my desk.
Yes, absolutely.
Thank you.
Oh, and
Thank you.
There's a small bite.
Oh, to carry it. That goes in my desk, absolutely. Thank you. And chocolate. Awesome. I love chocolate.